Thank you, Janet. Good morning, everybody. It's a real pleasure to see you all here and to see so many people. Hopefully, for the ones that were here yesterday in Cologne, you enjoyed the reception and you took the opportunity to have conversations, because this is what all this event is about, just to have conversations to find out what is the best way to bring AI into aviation in a safe, sustainable way. As Janet said, this event is a yearly one. This year we have a record attendance, and we are already planning for next year, which seems to be even bigger. So we are looking forward to go through this one, but as well to gather your thoughts through these 2 days and understand, what do you see as challenges, but as well as opportunities on the AI world. Over the next couple of days, we will have an in-depth conversation, and I will go through the agenda of the 2 days so you know what is coming. But we need to reflect not only on the opportunities that artificial intelligence brings to us, but as well on the responsibility that we have to bring these opportunities in a safe way. So basically, when we use AI, we are all confident that it's going to help the system and not hurt the system. And this is not an easy thing. And we were discussing yesterday in one of the conversations with some of you that nobody has the right answer to this question because it's a very complex one. So now more than ever, we need to work together to bring all the different inputs to come up with the best possible solution to this really complex, I wouldn't say problem, I will say challenge, or challenge, let's say like that. So it's no longer on the distant horizon, as you know. AI is here, and you probably are using it on your daily lives. So no, it's not something that we can ignore, but we need to embrace. And actually, it's redefining how we design, certify, operate aircrafts, and it will enhance safety and efficiency across the aviation ecosystem. So this conference provides us with a unique opportunity to exchange, to challenge, to build collaborations, and to guide us towards a future where innovation and safety advance hand in hand. While the official start of the EASA AI Days takes place today, our journey already started with a meeting that you had with the team earlier in the week with the international partners. Because we value, of course, all the input from the European partners, but as well from all the global community. And I was going to say aviation, but as you know, AI is everywhere. It's not an aviation topic per se. So we need to work with all the sectors. We need to learn from others. We need to share information with others. And we need as well to possibly make stakeholders that don't come from the aviation domain understand what are the challenges that we face in aviation, because as you know, it's a very specific sector. So apart from the valuable presence and contribution of our European partners, as I was saying, we have here civil aviation authorities from across the globe and industry as well, representing regions as diverse as North America, Latin America, and as well Asia Pacific. So their active participation and perspectives have already enriched our discussions, and their presence today underlines the truly global dimension of AI in aviation. This was possible due to the convergence of efforts between EASA AI program team, which I very much thank you. I mean, they worked really hard to put this event together, but it's not just this event. I mean, throughout the year, they are doing a significant work to understand what is coming, how do we fit it into the system, and as well, how we engage with all of you to make the best, as I was saying, the best possible solution to this interesting challenge. So thank you very much, team. So it's through this spirit of international collaboration that we can address shared challenges and seize the opportunities and synergies, considering the complexity that we live in aviation today. So as you know, the traffic is growing, we have less airspace, we have new risks like GNS jamming and spoofing, cybersecurity, weather patterns that are changing due to weather change, climate change. And then we have these enablers, but as well challenges and how to integrate AI into the already complex system. So as I was saying, now more than ever, we need to work together to understand what is happening and to see the best way forward. In the past, I don't think we saw very often that we were sitting in the same room with the FAA, with other regulators, as I said, from Latin America and Asia Pacific, and exchanging on this very open forum. So this has not happened, and I've been in aviation for 30 odd years. So yeah, I shouldn't say that because it shows my age, but it is what it is. We just have to be honest with each other. So what I'm trying to say is that this is fantastic, and I would say, is now happening. This level of cooperation is never seen before. So we very much welcome your input throughout these days. So without going any more into the wider picture, I will describe what is happening day one today. So on the first day, we will focus on the implementation on the AI roadmap, EASA AI roadmap. We will begin with a high-level overview, followed by detailed updates of the project managers on the rulemaking process, including the work towards the Notice of Proposed Amendment, our MPA, because we have an acronym for absolutely everything, and the concept paper proposed, the issue 0.3. Following these updates, participants will join in a workshop. And this is the first time that we do a workshop. And why? So the team was thinking last year how we can best use this opportunity to have you all here and online. Well, the online, I understand they don't participate in the workshop per se, but we have 190 people here. So it's difficult on the networking event to talk to everybody and to share ideas with everybody. So the workshop is aiming at bringing that interaction that will be very fruitful, because then we will get specific outputs that then we can use in our thinking and our future roadmaps. So the workshops will address 3 themes. The first one is AI assurance. The second one is the human AI teaming. And the third one is ethics-based assessment. So these sessions, as I said, are essentials for us, and please do participate as much as you can. We need your input. Following that, we look forward to the flash talks provided by the FAA and Eurokai. So thank you very much. And then that will close day one. Of course, in the meantime, you will have breaks, lunch, photos, things. That will be interesting as well. And please do, and the dinner, of course, another opportunity to network and engage with each other. And that will lead into day number 2. So the second day will be focused on the AI research and innovation projects. Most of you, or many of you, will be aware that we have IPCs, which is Innovation Partnership Projects, which are aimed at having a bilateral exchanges between industry and EASA to understand what are the innovations that are coming, in this case, AI-based, so we can assess if our regulations are fit for purpose or how we need to change them through the project development and implementation of the idea. So the first IPC that will be presented is called Beacon Project, and is from Boeing. And it's about auto-taxing systems, which raises insights on achieving level 2 AI, considering the human factors and systems perspective. This IPC also triggered important considerations around the notion of advanced automation, highlighting both its potential and its challenges, because we are now talking about how to work in a team with AI. This leads into a panel discussion on ensuring effective human oversight in highly automated systems. The second project, the next IPC, explores the use of generative large language models to support aircraft maintenance by improving documentation search and troubleshooting. While offering efficiency gains, it also raises key questions about reliability of the data and the information we get out of it, validation, and whether such solutions should be formally qualified. Issues to be further discussed in a panel. And the third one, which will conclude the day, is presentations from CESAR, 3 research activities showcasing advancements in aviation AI and reinforcing the value of IPCs and research projects as regulatory sandboxes that inform concept papers and AI regulations. So this is exactly what I was talking about at the beginning. this is a sandbox, a safe environment to test and try things before they go into operation or certification. So this is extremely valuable, and we want to share with you the progress on these 3 IPC projects. As we look ahead to the sessions, panels, and exchanges that will take place over the coming days, I will invite all of you to engage actively, to share your knowledge, your perspectives, and your challenges, because we have here as well different stakeholders, regulators, industry, academia, all of you. I'm sorry if I forgot any stakeholder group, but all the perspectives are very valuable because, of course, we have sometimes, many times, different ways of seeing the same thing. So we need to understand why. And I was talking to the colleague from the FAA yesterday, exactly that thing. We may have different views, but let's understand why, and let's see how we can, as much as possible, harmonize. So then industry will have an environment where it's possible to operate without barriers, because aviation is global. We don't stop when we pass from one airspace to the other. We need to make it harmonized, interoperable as well. So this conference, as I said before, is not about listening or talking, but it's as well about building dialogue between all of us and building relationships for the future, so we can use those throughout the year, not all in the conference. And then I take the opportunity to invite you to read a really interesting piece of work that my colleague Ines has been fundamental to put together, and the team of AI is the Ethics for AI in Aviation. So this is very interesting, and it brings lots of insights into how to deal with AI and what is the relationship with ethics. So I had the booklet, and I was going to bring it to show you. There it is. And it's on our website, of course. So I wouldn't say, as we always say, oh, it's a nice bedtime story. No, it's a very interesting document to read it in the day when you are fully awake. Fully awake. So I'm still a bit, I haven't had my coffee yet. So, right. So without any more delay, I'm going to thank you all again to be here. Wish you a very good conference. I will be nipping in and out. Wish I could be here for the whole time, but yeah, I'm sure my colleagues will let me know everything about it. And I want to introduce the next speaker, which is Christine Berg from the European Commission side. Christine is the head of unit for aviation safety of DG Move, and as well Deputy Director General of DG Move. And she will do a keynote speech providing the broad perspective, in particular the essential governance aspects impulsed by the EU AI Act, that, as you know, is the overarching act for the European Union, and the one that, of course, we need to consider to do anything on AI, EASA for aviation. So, Christine, the floor is yours. Please go ahead. Thank you.
Thank you, Maria, and hello to all the participants in the room and online. And I hope my online participation works and you can all hear and see me. Can you give me a thumbs up, Guillaume? Thank you.
Very well. Thank you, Christine. Please go ahead.
Good. Thank you. It's a pleasure to speak here today at the EASA AI Days for me, and I regret that I cannot be personally with you in Cologne, but it is what it is. Nevertheless, I also have a number of colleagues online, and they are also very interested in following your event. Thank you also, EASA, to have organized this event, which comes at the right time, because we are at a pivotal time for both artificial intelligence and aviation. As you have just heard from Maria, AI and the work of EASA is already deep into dealing with the practical challenges of integrating AI into aviation systems. And from our perspective, we would like to invite you today to look with me to the broader perspective, as Maria has said, and to reflect the wider vision of what the European Union thinks about AI and how AI policy connects with transport, innovation, but also our strategic goals as a union. We think this is important because it is quite significantly different on how other parts of the world are approaching the subject. Whilst, for instance, and it was mentioned by Maria, the US has decided to unleash the power of entrepreneurial advancement to the maximum when it comes to AI. And for instance, China continues to drive the matter predominantly by the state. In Europe, we have opted for ethical and public policy considerations within which we want to promote innovation by businesses. And I'm glad to hear that a booklet has been published also on the ethical considerations of AI in aviation. Now, in Europe, our co-legislator has coined the so-called AI Act, which is a regulation and which is representing a decisive step in shaping the rules for the digital age in all sectors. We think this is not just another law that has come out, but this is the foundation for how we will apply AI in ways that protect safety, empower innovation, and ultimately support our citizens. And I'd like to underline support and not control them. The AI Act represents, as such, the world's first comprehensive legal framework for artificial intelligence. As always with the first, it is probably not flawless. However, it aims to ensure that AI systems used are safe, trustworthy, and aligned with fundamental rights and values, whether used in consumer applications or in high-stake domains like ours, the safety-relevant aviation industry. At the same time, this AI Act recognizes the role of existing sectoral legislation and existing governance bodies. So for high-risk AI systems already subject to specific EU law, such as civil aviation, this new legal AI framework in Europe allows for sectoral conformity assessment procedures to take precedence. What does that mean in practical terms? It means that EASA will continue to be the competent authority for certification and oversight of high-risk AI systems in aviation in accordance with the rules that govern the agency. We, and I'm here speaking for a Director General in the Commission dealing with transport and mobility, have closely worked with our colleagues dealing with connectivity and communication technology and IT. We have closely worked also with our co-legislators, the European Parliament and the member states of the European Union, to achieve legal clarity, which was quite challenging in developing this act. We tried to safeguard both innovation and safety, and we wanted to avoid duplication or fragmentation of responsibilities. Now, we think this is a good example of smart regulation, bringing together horizontal coherence with sectoral expertise at the core. And let's face it, sectors have particularities, but when it comes to data and AI, nobody is 100% unique. So we need that combination. When we look at the transport domain in general, and AI in aviation in particular, we see that it is more than theory already. We see that AI is deployed to optimize traffic flows, to enhance predictive maintenance, and enable autonomous systems. And you will do deep dives on these subjects in the event. The potential of AI is also vast, but so are the safety and, more particular, the certification challenges for those who are involved in this work. Because of the safety critical nature of aviation, we need systems that are not only intelligent, but they should also be explainable, reliable, and as I said, certifiable. EASA's work, including the EASA AI roadmap and the existing guidance on machine learning assurance levels, are essential elements in addressing these questions. From the Commission side, we also support efforts that ensure that transport and digital policy evolve in tandem. Whether this is through our drone strategy 2.0, the objectives of the single European sky, or dedicated funding instruments such as the CESAR joint undertaking, we are committed to enabling AI adoption in aviation in a safe and responsible manner for the benefit of citizens. In emerging domains such as drones and advanced air mobility, AI is not an optional feature, as you may think. No, it's a fundamental enabler. Operations beyond visual line of sight, dynamic routing in use space, and autonomous navigation all depend on data-driven, adaptive, and AI-enabled systems. Let me say a few words also on governance and cooperation, which, as Maria has said, are important elements in a global sector as aviation. As artificial intelligence cuts across all sectors, the governance must reflect both horizontal coordination and sector-specific responsibility. We are in the process in Brussels of creating an AI office in the European Commission, which will play a central role in overseeing implementation across the Union, working in collaboration with national AI authorities and other institutional actors. When it comes to safety critical systems in civil aviation, however, the governance, as has been recognized by our legal framework, will remain distinct, and here EASA is the point to turn to. This is why the AI Act includes these specific provisions for high-risk systems that fall under existing responsibilities of union regulators in many different sectors. Such systems will continue to be certified and overseen by EASA and, when relevant, the national aviation authorities in accordance with how the EASA basic regulation foresees the cooperation. We think it's therefore essential to ensure that the roles and responsibilities between the different actors are clearly defined. And admittedly, there maybe more needs to be done. EASA and national aviation authorities retain the full responsibility for the oversight of high-risk systems in aviation. The governance structures established shall not interfere with this framework, but ensure overall coherence and coordination at the interfaces where necessary. And this is work that needs to be done and to be defined. This clarity is not only important for legal certainty, but also for enabling innovation without compromising safety, in our opinion. It should allow the industry to understand which regulatory pathways applies, and it should foster smooth deployment of AI in aviation. Like with any fundamental rule that has been designed, as I have said, this is a first. There may be room for improvement, and we are inviting everybody to work closely with EASA to indicate that potential. However, that should not mean sit back and wait for any changes, but fully embrace the framework we have and set aside what needs to be improved in the future. Dear colleagues, dear participants, Europe has opted for responsible AI regulation. In aviation, we have an opportunity and a responsibility to go further. We think AI must support safety and not compromise it. It must enable innovation and not constrain it. And it must reflect our values, even at 30,000 feet. We from the Commission are proud to work alongside EASA and all of you to make this happen. We think that together we can ensure that aviation becomes a truly global benchmark for safe, trusted, and innovative AI. Thank you from my side, and I wish you a productive and interesting day. Back to Cologne.
Thank you very much, Christine, for taking the time to join us today. It's really appreciated from our side, and that was a great overview and a great start for things here. We're going to move on now with our first speaker from EASA, apart from Maria, so actually our second speaker from EASA. I'd like to introduce to you now Guillaume Soudan, who may not need much introduction to many of you. He is the head of our AI program here at EASA. Thank you, Guillaume.
Thank you, Janet, and welcome everyone. Nice to see so numerous people in the room, and we know we have a lot of people on the WebEx as well. So it's great to have such a forum for exchanging this week. Just a minute for me to project the slides again. Exactly. So I will begin I would say the technical part of the workshops we will have today with a top-level view, 40,000 feet probably, of the AI roadmap implementation. So really taking what's relevant, what happened in the last year compared to what we could discuss also a year ago, and what is meaningful to provide you in order to really better understand the directions we take, the sounding we are trying to do also with the workshops. You remember one of the conclusions of the last AI days was we need more interaction. We need also workshops on specific topics. That was probably something we wanted to do a bit earlier, but we finally said, let's take the chance of these AI days to have these workshops internally here in-house. For sure, it's the beginning of something that could be even more interaction, and that's a great thing. After the topics we selected are obviously the most pregnant technical elements of the roadmap in terms of building blocks. But definitely we have a lot on the plate, as you will see in the coming slides. From that perspective, I always start with this slide. You know it by heart, but it's always to locate where are we on this roadmap that we started 5 years ago with the first roadmap published in 2020. From that stage, we engaged in an exploration phase. We already talked about it, but I'm always saying it's a blessing that we could do that. It was not necessarily the case for other topics in the past. And we could really engage with innovation partnership contracts, with research, also with first applications and certification projects engaging in order to see what is the challenge, how do we deal with it from a global perspective, meaning global in aviation. We know AI is not only addressing certain domains, but actually is a wide spectrum impact on a lot of domains. So we kept this logic of multi-domains. We saw also from this initial roadmap that it's a multi-expertise base or flavor. Of course, there is systems aspects, system development. Of course, there is human factors, but there is ethics aspects as well. And we are engaging with the concept paper issue 3 into the anticipation of what advanced automation will mean, where the human is not necessarily in the loop of operation. And that's a novelty for aviation. And we need to see what it means for us, and it engaged actually in a variety of expertise. We also have, and from the start, recognized that we have different types of AI in the nature connected, in fact, with the level of automation. We didn't call it level of automation because we have a lot of automation schemes already available. We didn't want to make like yet another automation scheme, but we said, let's call it levels of AI. And with these levels, we can characterize a type of interaction with a human, or at the end of the day, probably without human in the loop of operation, but still keeping an oversight, a human oversight from the development phase up to the mission definition. And that will be key in the next year, I would say, when we engage in the concepts for the issue 3 of the concept paper. So you can see that at the top, and the level 1 is pure assistance to a human fully in control of the operation, including any decision making. And then we have this notion of human-machine teaming. That's something we are exploring and exercising with use cases now to see how we want to define that, how the terms match the reality. And we turn in 2025 towards level 3 AI, advanced automation, where a human could be still a remote operator, but not involved in 100% of the operation, or even no human at all during the operation. And that's level 3A, 3B. You will hear about it from the other presentations today. That's quite a challenge from the start. And it's also looking back to the presentation or the speech and the keynote speech from Christine. It's connected also to the AI Act. The AI Act has an Article 14 on human oversight, which we need to take very carefully into consideration, especially when we start having a level as advanced as level 3. So we kept this logic of an exploration phase. We are in the consolidation phase. We already entered into it last year. We presented extensively what we were planning. You remember that it's a twofold exercise, I would say. One is focusing on the rulemaking, first rulemaking for the initial scope of level 1, level 2, which we elicited in the concept paper issue 2. And the second big element is this anticipation in the concept paper proposed issue 3, because we will consult, like we did for the previous concept papers, of everything that will be level 3 related. But also, you will see a lot of details in the presentation from François Triboulet, an extension of the technical scope beyond the sole aspect of machine learning. We have more AI on the plate, and that's really important also to consider. At some point, we will be in 2028, roughly, with a capacity to push the barriers. The limitations we've introduced might be needing quite additional consideration. So we'll see that. Probably Roadmap 3.0 will come at that time, but this is really prospective. Let's first engage in the finalization of the consolidation phase. We were always driven by the prognostic from our industry. It's only prognostics. We never say these are dates to bound things and to prevent things from happening. We need to go with the pace of innovation. So we follow you. And yeah, I think you know this view, and that's a top level element. What I wanted to also reflect on is this notion of collaborative approach. The fact that we have so many people and so many different stakeholders in the room and online today shows this shared commitment we have to advance innovation, to keep also and maintain the high standard of safety with these new technologies. We definitely have put our roadmap somewhere in the center of a lot of interaction, of course, with our industry partners through the advisory bodies, but also concrete certification projects. We have, of course, a direct connection to our management, whether at the European Commission level or at EASA. And that was really, as I said, a blessing that we could engage in this overall roadmap effort from the start, and we get very supported. Thanks, Maria, and everyone in the room for that. Advisory bodies are also on the member state side, and we have also interaction on the topic with them. From let's say, a research and innovation side, we have, of course, bodies that we interact with and projects going on. You heard about MLIP in the past 2 years. We closed that project, but we are trying to engage in another project related to human factors aspects to do the same meaningful job like we could do with the machine learning approval project together with Airbus Protect, LNE, and Numalis on the side of the AI assurance. The scientific committee is also a very important body that we have in EASA as a sounding board for the directions we give and the concepts we investigate. And of course, we are looking into a connection with academia largely as we can, because PhDs are every year bringing us additional very important elements. Standards design organization, extremely important also to stay connected with EuroCAE, SAE, but also looking at what is happening at international level with ISO. Sensenelec for the standardization of the AI Act is a very important element also to keep an eye on. We are very engaged. You will see a presentation from EuroCAE a bit later, EuroCAE co-chairs of the working group on AI. And you will see that we have a very important, let's say, a connection with this industry consensus that is ongoing. On a part of the scope, you will see that we need also at some point to expand the view to human factors and probably at some point dealing with ethics and so on. From that perspective, you know also this slide. We have a concept paper issue 2 published on the website of EASA. You have the link here. Everything that we publish is available there. The concept paper is surely not a rulemaking artifact. It is a concept paper, meaning we wanted to investigate what are the necessary objectives we see on the plate. And that's not a framework that is, let's say, neither frozen. We are still evolving it with all the interactions I was mentioning on the previous slide. But we are also working on this next version, which should be the last, at least for the current roadmap, in order to expand the full view of what we see is in projects, is embedded in projects today. From that perspective, you know also the building blocks that we were always using. They are a bit like a convenient way of taking a 40,000 feet view on where or 30,000 depends on the aircraft, where we are sitting with this framework, with this technical framework. So I will not go in details because the project managers, the different project managers will go into details for each building block in a subsequent way, at least for what is novel. We are not trying to re-engage in all the discussion that we had also in the past. The point I wanted to say is, yes, we have this framework. For 5 years, we've been working on it, the nose on it, I would say, with the AI program team. But now it's also important to reflect what's on top, meaning when will this framework be applicable? When will it be called? And when do we need it, by the way? Because it doesn't mean that every AI in aviation has to be directly impacted by all of these guidance objectives and building blocks. And just to take again a high-level view, there is an obvious case where we want this framework to be put in place. In the rulemaking, we've worked on an NPA, first NPA that Maria mentioned on the framework itself. The second step is starting right now in September with the rulemaking group in order to see in a step 2, where do we and when do we call it, from which regulation, etc. So the calling to the trustworthiness framework will be done from the top. From the top level regulation, of course, certification, specification, detailed specification, and AMC, so acceptable means of compliance, guidance material. All of that will be carefully taken domain by domain. One case that is pretty clear, the case 1, is when we have a product or equipment certification or conformity assessment. We have things already in place, and what we need to do is simply to complement the existing with AMCs, acceptable means of compliance, or guidance material, GM, in the case where AI can be used, like machine learning, and in the case where a certain level of AI might be used, like a level 1 or a level 2 so far. The case that is a bit in the background as well is the case 2, when an AI-based tool might be used by an approved organization. And that's something that is a bit more in a fuzzy boundary, I would say, of the scope of the rulemaking. We are working on it with our colleagues at the European Commission to clarify exactly the scope. But let's hypothetically say this is something we should deal with. We have, and we will have to deal with it from a safety perspective for sure. Whether it is from the AI trustworthiness perspective, that's to be seen. Now, if a tool presents a risk without independent verification of the tool, and we really rely on the output, we better have a certain assurance on the intended function and capability to interact properly with the human end user. And that's where we go back to principles of the trustworthiness concept. Doesn't mean everything will apply. We will have to sort out carefully for a given tool or for tools what could be applicable, but that's bringing back to our framework. But aside of that, we have quite a number of cases where the tool might present no risk. Then I would say feel free to use AI if it's enhancing your business and your processes and your capacity to be efficient and to promote safety. Now, if it is presenting a risk, but fully independently verified from an output perspective. That's the case where we consider, and that's a very, I would say, limited risk that we take, that there is no need for qualification. We would not enter in the concept paper, in the rulemaking guidance that is in preparation. And that's a very important element that was not so clear so far. And I have to really turn also back to the rulemaking group and the rulemaking activities we are doing. Giovanni will present that in details later today. We used a lot this rulemaking group prototyping and anticipation to get to such a clarity even in our minds, because we were focusing again on the generic framework. Now we take a higher view and we know a bit clearer that not everything will be AI trustworthy, but not everything needs to be. And that's super important to keep in mind. So I would say more to come in the step 2 of the rulemaking and in the NPA step 2. But yeah, a lot of things to consider. From that perspective, the rest of my presentation will focus on some elements of where are we for each of the building blocks and what are the remaining challenges, so that you know also at which level of maturity, I would call it, we feel with the different building blocks, and where we see we need to really work together with the rulemaking group, but also with the concept paper development. So you see the building block logic. We have still the generic one that is the AI trustworthiness analysis. That's still, let's say, a vertical block that serves them all. And that creates this, you remember the potentiometers that are on the previous view, creates a certain proportionality. So for what is about AI assurance, the proportionality is directly driven by the assurance level. The assurance level is driven by safety assessment or risk assessment, as we know them in aviation. There is no change there. We will use the domain-specific, domain-existing guidance to say what is the necessary level of assurance. The safety benefits is something I will develop on the next slide. It's a concept to say we may have also to balance somehow the risk versus the benefit brought to safety. And we could have certain systems that are maybe not at the level of performance we would like from the start, because machine learning from a statistical perspective and nature does not bring a 100% of performance. We know it, but maybe there is such a safety benefit in the 90% or 80% or even 70% of performance that we need to set on it, and we would enable actually a kind of a way to address those a bit easier. I will have a bit more elements on that in the next slide. Another thing we recognize, and you see some use cases we were using to mature and further understand how this proportionality works. We have two types of use cases. Some are pretty high dimensional computer vision. We always talk about it because neural network is kind of the reason why we engaged in this roadmap. But there is more on the plate, and machine learning is not necessarily neural network. It's not necessarily high dimensional. We could have low dimensionality. We could have low complexity models. And we saw in some certification ongoing, in particular on the ROAS, on the runway overrun alerting systems, that there is a way to simplify even the objectives compared to what we were anticipating in the proportionality based on the assurance level. So there is even more on the plate where we could lower a bit the bar, but benefit still from the right objectives for certain case where we have data space dimension low or model complexity low. That's something I have underlined here to say that that's still a remaining element or effort to undergo. To see where we are today, we have guidance developed for machine learning in the EASA concept paper issue 1 and 2 for supervised and unsupervised learning. It's a reduced scope for a start. Based on 5 years of exploration, we had 3 IPCs dedicated to that. We had the MLIP project, research project I was talking about before. 500 pages of excellent report that gives us even more understanding of what are the means of compliance, the methods, the tools, and so on. And we have 2 certification projects, actually more than that, but 2 that have allowed us to drive this proportionality and understand also the convergence we see with the working group on the EuroCAE SAE side. Remaining effort, inclusion of reinforcement learning, logic and knowledge-based and hybrid AI assurance. That's something that François will talk about in the anticipation of the proposed issue 3 of the concept paper. Proportionality for low-dimensional, low-complexity model, that's still to be done. We will use the chance of the concept paper issue 3 to make a proposal. We can work, of course, with a working group on that further. Inclusion of service experience approach is one thing I put just as a remaining effort because it's a concept beyond the safety benefit that I will just describe in a minute. We see that service experience could come from other domains like automotive or why not the military domain. And that's something we need to anticipate. There could be, in fact, maybe a difficulty sometimes to port a certain model because it's complex. Maybe it's non-qualifiable from an AI trustworthiness or AI assurance perspective. And we could leverage some experience gathered in service with certain sensors, with certain elements from the automotive, like, I don't know, an awareness system that you have in a car, checking if the driver is drowsy. That's something that could be really anticipated for the aviation. One slide to go a bit deeper in this notion of DAL, of assurance level. Sorry, not DAL is for a certain domain, but assurance level is the way to generalize it to any domain. Progressive anticipated certifications, we see that we are done with the low complexity models. We can certify them. It was done this year. So we realized the 2025 prophecy, but not completely because we still have the high complexity model on the plate. We have some projects very advanced, but still running. So probably early 2026 will be the time where we see a DAL-D high complexity machine learning constituent for computer vision certified. And from that, we will have, it opens the door and the way to a DAL-C high complexity, which for those not knowledgeable with DALs and development assurance is asking actually is more safety relevant, therefore asking for a bit more objectives to be applicable. DAL A and B is a far, for us, is more farther than that. We don't see for now that we have a framework that enables it, but for low complexity, we could also start engaging. And then at some point, and I'm sorry, it's a bit blurry, but it was on purpose to say that the high complexity DAL A and B for us is not a reality yet. It's 28 plus, and we will see probably in the pushing barriers. Inclusion of a safety benefit concept, a very important concept. You know, it's for the people involved in general aviation projects, like the net safety benefit is already in place. A similar concept should be generalized for AI. We could have a benefit that is demonstrated that can compensate in some way the risk that we take, and we can probably anticipate the lowering of one assurance level in the case where there is a substantiated safety benefit. We have the example of the runway incursion detection system, whether based on onboard sensors like camera for EVS or other cameras, or ground-based cameras. So we have really the capacity with computer vision to address this safety relevant issue that is runway incursion. And that's something that we could enable by saying, even if the sensor doesn't work 100% of the time, everything that it detects could be actually life-saving. And that's exactly where the safety benefit could be coming in. From that perspective, I go to the human AI teaming challenge, which is something we developed for the level 2 type of applications. René will say a lot more about the concept itself and where we are going with it. But from a top-level perspective, the proportionality comes from the level of AI directly. Level 2A, 2B is proportionating this notion of human AI teaming. We could add up in the future 3A when we are done with the concept paper issue 3. Auto-taxiing system, you will see it presented tomorrow by the Boeing team. We have an IPC that was ongoing for 2 years, on which we investigated an auto-taxiing system at the level 2A, anticipating also what it would look like at 3A. And that was really a good driver for testing the different elements of the human AI teaming concept. It's not the end. It's only one use case, and it was a good one, but we didn't engage yet in a level 2B concrete use case. So we have still a lot on the plate to test the water, but also to let's say, work on the concept and the terminology. We have a lot of discussion on cooperation, collaboration, including yesterday in the sessions with the international authorities. There's a lot to still process, and that's where, from where we are, we have a bit less experience, but still 3 years exploration. Scientific committee has really helped a lot in the validation of all the design principles that were put in the concept paper. One IPC, the one I was mentioning, but an IPC, a very important one, where we had even the chance to go for an on-site demo. So it's a concrete project. It's not something just on the paper. And remaining effort, convergence with the subgroup 8 of the working group. You will hear it surely mentioned by the presentation on EuroCAE. A new subgroup has been created to especially look at the human AI teaming or human factors for AI aspects. Integrated approach considering enablers and automation. That's the thing I wanted to show on a slide. We need to be also careful on one thing with AI. If we kind of compare what is requirements-based traditional systems or sensors versus AI-based perception. Of course, development assurance matters. For the traditional, we know what to do and we don't need additional elements. For AI, you heard from the AI assurance building block, we need additional guidance. That's clear. But now from a more integration perspective with the human and the end user, we see a lot of difference that a classical sensor will be requirements-based first, clear, will be, for instance, if we take a visual landing guidance system based on AI, if we take the sensors we have today, like an ILS sensor, what the autopilot will do finally is just to react to a certain deviation from a signal on the ILS, so glide and slope. And from that, we trigger an autopilot system that then triggers actuators and gets the aircraft down even to the runway, why not, in a Cat 3. From that perspective, if we think now VFR only, but visual only, meaning no ILS at the aerodrome, but using really a visual landing system based on an AI-based perception system to drive a vector of guidance down to the runway, what happens is that the rule-based decision system remains the autopilot. That's okay. It will trigger the actuators and everything fine. But in terms of decision-making on what is the runway, where is the runway, we could have really a kind of a bias introduced by the system. Let's say the taxiway is considered as a runway. The rule-based autopilot will actually do nothing to prevent to land on the taxiway, because the taxiway was brought by the perception system as the element relevant to start the guidance vector. And this is exactly what we say. We need to keep a bit of a, I would say, an integrated view. The enabler is the AI. AI is just an enabler. That's very clear. It's not the automation. But the level of automation combined with the enabler AI could raise certain questions where, that's what I tried to do with a couple of words, where we see the need to not split the roadmap. And that's something we also said last year. Our roadmap on AI is an AI and automation kind of integrated roadmap for the AI side. After, you always have the question, okay, but some systems could be without AI. Yes, and they could be highly automated. Of course, no problem. We know that. For that, we have less of a concern because of this view, in fact, because we can still deal with it in a probably split way within system integration as usual, and it will work. For AI-based system, we really rely on the ConOps, on the ODD, to drive the big picture of the automation. And this is really an important element to keep in mind, even for the level 3 as it comes. To finalize the view, the advanced automation risk mitigation and the human oversight will be developed, in fact, in the last remaining block from the roadmap, the SRM, the AI safety risk mitigation. It was a bit underdeveloped so far. It was kept for the end, for the level 3. And we developed some guidance in the last 2 years with the scientific committee, our scientific committee participation and validation, and with one IPC, and we have one TAC in preparation, a technical advice contract with an applicant on the side of drones and level 3 of AI. And that's where we are also discussing with our colleagues on the FAA to probably engage on an IPC, a joint kind of innovation partnership. We know an applicant who is very interested to carry on work with us on that, going on the level 3 and on the reasoning element, which is part of the extension of the technical scope. We need an inclusion of a complexity criteria. We see that level 3 AI will not be always at a level of complexity that requires also a big picture of AI trustworthiness and totally additional objectives. We see a lot of proportionality from the complexity that could be a third driver, and we've put it in the proportionality driver beyond the product type. Product type clearly proportionates the certification framework or the conformity assessment framework as usual. Okay, and that's exactly where I will stop. So the perspective, you can understand from this presentation that the next 2 years will be decisive. It's not the end, but we will have a lot. So we expect a publication of the first standard for machine learning from the EuroCAE SAE side. We expect a recognition through the rulemaking exercise. The first NPA will already anticipate that to deploy it in the relevant domains by end of 2027. And we anticipate this publication of the proposed issue 3 of the concept paper to enable the technical scope extension and the advanced automation guidance, preparing the next rulemaking task steps as Giovanni will present in this afternoon. This should secure a first stable regulatory state. Of course, if we don't get a new AI breakthrough in the meantime, we know there is a lot going on every front, and let's see what comes. But the pushing barrier phase 3, at some point will be anyway the place to take over any consideration on completion of the extension of the rulemaking scope and removing limitations wherever they are in criticality, in adaptivity of systems and so on. Thank you very much for your attention, and now you will hear after the break from the project manager. Thanks very much.
If you could please take your places in the room, because we're now ready to start. We also need to really keep on time, in fairness to the people who are joining us remotely, because it's much more difficult from that side to see what's going on. So we're now going to move into the question of trust. And trust is really everything, right? And so to what extent can we actually really trust AI within aviation? For this, we have 3 project managers from EASA who are specialists in this area who are going to talk to us. We're going to start off with François Triboulet, who will talk about AI assurance. Then we will move on to René Pelchin-Medved, who will talk about human factors. René, unfortunately, has to join us online, but we're very happy that she can still join us today. And then Ines Belenga, who is right at the front of the room, who is the author of this, and will be talking about ethics. Just on this particular item here, please only take 1 each. We have a limited number of copies, and if you start to pack them for everybody at home, then that will be somewhat complicated. It is on our website. If you've already snuck away 10 copies, can you sneak them back again, please? Because we really need to make sure that everybody can get one, but we just need to control it a bit. So I'll leave this now, so I'll hand over immediately to François. Thank you.
Thank you very much, Janet. It's really a pleasure to be with you today and continue to share what is our progress and what are our visions for the coming years. Okay, I will start with this picture that illustrates from a different perspective what Guillaume already introduced with the roadmap that we are executing and this consolidation phase by sharing with you the overview of what will be in the scope of this second phase of the roadmap. I will start with the rulemaking activities. These are managed under RMT 0742. I will not go into the details as Giovanni will drive you through what is the progress so far and what are the next steps with this activity. As already explained by Guillaume, in parallel of this entering into rulemaking, we continue our exploration because we know that we are not at the end of our journey. Already from a machine learning perspective with supervised learning, we know that we still have to learn, But in parallel, we have to continue investigating some other technologies, reinforcement learning, for example, and technologies linked to logic and knowledge base, and the hybridation of all these technologies. We also have to extend our guidelines with human factors aspects, and René will develop all these aspects later during the day. And of course, we have to continue our journey looking at the ethics aspects. We have a first report available, but we will have to continue looking at, because of this first report is mainly dedicated on the professional views, but there are some other aspects to address related to ethics. It is also part of the human factors for AI, but when we move forward with this advanced automation, there will be some other aspects that will come with the issue 3 of the concept paper, and Guillaume already mentioned this via the safety risk mitigation technical block that will need some further guidance. Guillaume already mentioned this as part of, it's also in the context of the exploration with the explosion of generative AI and LLMs. We have to consider LLMs in our roadmap, and especially in the context of their usage with operational tools, but not only, and I will discuss that a little bit. So the first part of my presentation will be dedicated to the rulemaking activities that we have in the context of AI assurance, and knowing that the second part will be more focusing on what will be in the issue 3 of the concept paper with the technical scope extension. So if we look at the rulemaking activities and the different sets of NPAs that are in preparation with the rulemaking. From an AI assurance perspective, we focus first on some aspects related to assessments in the concept paper, so safety and security assessment, and this will be reflected into requirements on risk assessment in the NPA. For the technical block and the AI assurance, what has been developed in the concept paper will be translated through requirements on the AI/ML intended behavior, and also, if we look at the data recording aspects, they will be reflected more under the continuous safety assessment aspect. And very important, the risk assessment will proportionate, from an AI assurance perspective, will proportionate the requirements that will come on the intended behavior. I don't want to really go into the details of the structure of the rulemaking. However, it is important to have a high-level view before I go into the details of how this is being reflected on the rulemaking for the AI assurance aspects. So this view will be probably further detailed this afternoon by Giovanni. But okay, what is important to understand is that first, in terms of phasing, we have different steps in the rulemaking. So far, we are running or executing the step 1 of this rulemaking, and via this step 1, we will deliver an NPA that will be consolidated under what we call a DS, so a detailed specification. And this detailed specification will address the technical requirements that will apply to all the aviation domains. So it is a generic detailed specification with its set of requirements and also its sets of AMC, so acceptable means of compliance, and GM, guidance material. During the second step of the rulemaking task, the work will be to interface this generic framework with the existing regulation. And here I have put the focus on two different aviation domains, the ATM-INS with its regulatory framework composed of the 2017-373 and the new regulations associated to the conformity assessment that is now being deployed in Europe. And we have considered another example with the initial certification and the existing CSEs for large aircraft and so on. So this interface, as you can see on the slide, it will be as necessary. So when existing requirements are at a sufficient level of detail in the existing requirements, they will not be directly interfaced to the requirements level of the DS. The interface will take place at the level of the AMCs and guidance material. So it is very important to understand that, and you will see how this really works for the ATM and for the initial airworthiness domains. So if we now move to the instantiation of this framework into the ATM domain, and if we consider first the risk assessment requirement, so we have on the left part the generic framework with the level of requirement, so a requirement very high level on the risk assessment, and this requirement is accompanied with a set of AMCs. There are in the AMCs there are general AMCs and more specific AMCs with taking into account the specificities of AI. The generic AMCs are at the moment more a provision in the case this general DS will apply to domains where there is very little at the moment in terms of safety or risk assessment. So for the ATM domain, with that is developed on the right part of the slide, this level of AMC does not need to be interfaced with the regulatory framework as it is existing at the moment. Now, if I go into the details of what happens for the ATM-INS domain, we know that in Europe, with the 373, there are requirements from a safety assessment perspective. There are requirements applying to non-ATS providers, and there are other requirements applying to ATS providers. So these are the two columns that you can see on the right part of the slide. For non-ATS requirements, we have an Annex 3 subpart C with one requirement that is ATM-INS or C005. This requirement has a set of AMCs already existing, and for the with the rulemaking task, the objective will be to interface the specific AMCs of the generic framework, so the AMC2 plus additional AMCs for the safety benefits. They will directly interface to the existing AMC of 373. And the same applies to ATS providers, so the right part of the slide, with the requirement ATS OR.205. So as a summary, no interface at the level of the requirement and really dedicated interface when needed at the level of the AMCs and GMs of the generic framework. And the same applies for initial airworthiness. Now I propose to move towards another requirement, which is about development assurance. Again, same principle applies. So we have this, you will find in the NPA one requirement addressing the system intended behavior. This requirement will come with its sets of AMCs. Some will be generic, some will be more AI specifics. And again, for the ATM domain and for the two sets of requirements depending on the operations by the provider, be it a non-ATS provider or be it an ATS provider, the interface will take place at the level of the AMCs. So no direct interface at the level of the requirements. And again, the same applies to the initial airworthiness domain. Here again, the interface to CS25 1309 will take place as at the level of the AMCs of 1309. So that was the part of the presentation addressing the activities related to the rulemaking task. Now I switch to the exploration and what is currently being worked in the context of the issue 3 of the concept paper. I want to start with this view that probably most of you already know. We are constantly reviewing this taxonomy, taking into account the deliverables by the Commission and the definitions that you can find into the EU AI Act. And in the EU AI Act, there is this definition of what is an AI-based system or an AI system. So on the left, we have this box related to machine learning. In the issue 2 of the concept paper, we significantly address machine learning, but the scope was limited to supervised learning, extensively developed in the issue 2, and we started to provide some guidance for unsupervised learning. Now, with the issue 3 of the concept paper, we have to extend the guidelines considering reinforcement learning, which is another technology consolidated under machine learning. I will present you more details about what are our views so far with regards to reinforcement learning. On the right part of the slide, you have a box that we call logic and knowledge-based approaches. This box also reflects the definitions and the guidelines proposed by the Commission under the EU AI Act and its more recent guidelines. With all these, with logic and knowledge-based approaches, what industry has in mind are applications dealing with knowledge representation and reasoning systems. Very important is to consider as well the hybridization of all these technologies. We see already applicants coming with solutions or AI-based systems that will mix machine learning and knowledge base. A typical example is a system that would have one constituent dealing with some perception, cognitive elements, and that will be complemented by some reasoning in order to sometimes to consolidate the view of the perception achieved by the machine learning system, or delivering more advanced decision making based on the perception. So we see applicants in this area, but also we have considered so far on this picture that LLMs could enter into this notion of hybrid AI. We all know the architectures of these LLMs. They mix different technologies, machine learning technologies, supervised learning, of course, with the transformers, but also reinforcement learning with the feedback loops brought by the human at the end of the learning process. So far, we have considered LLMs as a kind of hybridation. Very important, it was already an important element of the issue 2 of the concept paper in terms of limitations. So so far, no guidelines for systems that would have failure contribution above major failure contribution. And also, even that could be limited to minor in some technologies. So we are not absolutely sure and confident that we will be able to propose guidelines for some of the technologies that we will discuss just after for more safety critical systems and systems having a major failure contribution. The second aspect that is very important is the notion of related to the offline learning. So far, we are not able to propose guidelines that would consider systems that would continue to learn during the operations. So from our perspective so far, the models will have to be frozen at the end of the development before they can be deployed in operation. But then comes the point that we will have to make sure that we can rapidly adapt the models once they are in operations in order to benefit from the lessons learned from these operations in order to improve the performance of these models. So this is another aspect that we will have to take into account. So I propose to move to these different technologies, starting with reinforcement learning. So from a high-level perspective, most of the reinforcement learning solutions that we see on our door are implementing the Markov decision process paradigm. So just a few words about this. We consider a system with an agent interacting with its environment. The agent is in a certain state. It can take actions from this state. The environment will analyze the effect of the actions being taken by the agent and will deliver a new state for the agent. And in parallel of the new state, it will deliver a reward for the agent to take another action, the next action. The reward can be positive or negative, depending on the situation. So naturally, by looking at this picture and this architecture, we can conclude that reinforcement learning is significantly different from supervised learning. Supervised learning is single decision making. Reinforcement learning is about sequential decision-making by nature. So this is very different. In terms of learning, most of the algorithms that are being used in reinforcement learning are based on the trial and error approach. So there is this notion of episode where the system could fall into really a failure mode, and then you start again a new learning episode. Also, with reinforcement learning, it is not only about data, it is about scenario. And this is quite different from supervised learning. Of course, and this is something that we have been working on with the standardization group, we can explore scenario-based testing in supervised learning. But in reinforcement learning, scenario management is paramount. Yes. Okay. Okay. Sorry. How many minutes do I have? Okay. I'm too verbose. Okay. Additional. We have identified some new challenges coming with reinforcement learning. And for these challenges, we have consolidated them from an environment perspective or from an agent perspective. From an environment perspective, the defining, implementing, managing the environment for reinforcement learning to make sure that it will closely mirror what will happen in the operations is a challenge. I will not go into all the details of and all these challenges, but just for example, to reflect on one of them, uncertainty. When the agent takes an action, let's consider, for example, the case of conflict detection and resolution. The agent will propose a clearance to the aircraft. Of course, there could be some latency when applying this clearance. The environment will have to reflect on these uncertainties. Same for the agent. One particular very important one is the partial observability. It can happen that for some use cases, the environment can be only partially observable by the agent. So this is a challenge that will need to be addressed. Globally, I would say that this is the seam to real gap challenges that we will have to face with reinforcement learning. If we move to LKB, we try to first to exemplify what could be a logical architecture of an LKB AI-based system. And so we have on the left the knowledge base with possibly an ontology, a fact base, and based on this knowledge base, there will be a reasoning or inference engine that will propose a decision or make decision based on the exact situation at the specific time in the operation. The LKB comes with some other challenges. The first point that we think is very important is to really delineate LKB from, I would say, traditional software systems like expert systems that are already approved. So it will be important to not to reinvent things that are already available and already exist. So the first difficulty that we face is to identify this boundary. And second is the knowledge representation. So we have to consider the accuracy and the completeness of the knowledge representation so that the inference engine, the reasoning system can be effective and efficient. With hybrid AI, So I already mentioned that there are two different categories of hybridations that we consider at the moment. Okay. In terms of challenges, with hybrid AI, there will be all the challenges that are already existing that will largely apply. There is one that comes on top of it. It is about hallucination. So we will have to take care of these phenomena with LLMs and make sure that all the systems that go into operations avoid this kind of phenomenon known as hallucination. If we look at the perspective, we are confident that at system level, everything that was developed with the issue 2 of the concept paper will still apply. So the characterization of AI with the definition of the high-level task, the identification of the ConOps and the ODD, they will remain whatever the technology. From what we expect with in the coming months, it is to benefit from all the interactions that we can have with all of you. I will just mention the CESAR use cases embedding reinforcement learning. And very interesting, we have one case with an LLM that could be used in the context of a safety critical application. So this is a very interesting use case that we will pursue in the coming months. Just in terms of timeline, so our objective will be, it was already mentioned by Guillaume, to apply the same process and the one that was applied for the issue 1 and issue 2, meaning that we will go for a public consultation once we are ready with a proposed issue of the issue 3. We will process the outcome of the public consultation before publishing the final issue 3 of the concept paper. And our objective is that this will be at the end of 2026. So you could expect a proposed issue 3 around Q2 2026, hopefully early Q2 2026 for the public consultation, knowing that we will go through a focus consultation before that.
René, do you hear us? The floor is yours, and I will manage the slides if you want.
Yes, can you hear me? Can you see me?
Yes, and we can see you. Perfect. Yes, all good.
Perfect. Thank you very much. Thank you very much. It's great to be still online. Would have preferred, obviously, much more to be on site with you all. But also, I'm very grateful that Andy Kilner is there, Andrew Kilner, my colleague. So if you have during the breaks questions, I'm sure he is happy to answer all your human factors related questions as I'm not there. Thank you very much, Andrew. We can start with the slides. Yes. So I'm coming back a bit to also what Francois just showed. You see here the building blocks, the trustworthy AI building blocks. And why am I showing this? It's because the human factors for AI topic, the different chapters on operational explainability, human AI teaming, and the modality of interaction, as we have that also in the concept paper issue 2 at the moment, are entirely driven by the characterization of artificial intelligence, so of the different AI levels. And why is that? Next slide, please. I'm sure you know this table very well. It shows our 6 AI levels, level A, 1A to level 3B. And it is important for the human factors chapters and the human factors elements simply because we are really talking about human cognitive processes in the beginning, and then the interaction between the artificial intelligence system and the end user, so the human end user. So as you know, level 1A and level 1B, it starts from information acquisition, the analysis of the information, and then goes into decision making. In level 2A, 2B, we are really going into the cooperation and collaboration between the AI-based system and the human end user. So where we are really talking about interaction between the two, active interaction between the two, communication, etc. So it's a directed decision and automatic action implementation and the supervised automatic decision. And then what we will be dealing in future with is level 3A for the human factor side. And then of course there's also level 3B, which is not of so much interest for us on the human factor side any longer. But 3A is the safeguarded automated decision and action implementation. So we are coming from a full authority of the end user on the lowest AI level up to a partial one, then even a limited one, and then we don't have the human in the loop any longer at the end. So these steps, these levels obviously determine the entire content of the human AI chapters, objectives, and then also the parts in the rulemaking task. Next slide, please. What do we have in the concept paper issue 2 at the moment? We have looked at different human factors concepts that are relevant in the cooperation, collaboration, or interaction in general between the AI-based system and the human end user. So everybody obviously knows the term situation awareness, defined by Mika Ensley a while ago, which is the perception of elements in the environment within a volume of time and space, with the goal to comprehend the elements and to project the status into the near future. Everybody knows about that. What we did for concept paper issue 2, we defined the same kind of concept for the system, which we call situational representation. Here it is important that we are talking about the collection of elements on the environment as well as the system state, but also the state of the end user. Then this information will be processed with the goal and the aim to enable the extrapolation of a target status in the near future. So these are the two concepts. One is very well known, the other one is transposed for the system. So that's what we did in concept paper issue 2. The same for validation. Validation is known already today. If we talk about readback, etc., one partner, one team member is validating what the other one says. So we have to do the same for the AI-based system. It has to be able to provide information to the end user, but it has to be able also to cross-check it. Then if the system and the end user coordinate with each other, and communicate with each other, there are different ways to do this. So we have the spoken natural language, which is what the human natural language as we do today, understanding human language and use the same language back and process this language. Then we have spoken procedural language. In aviation, obviously, we know procedures very well. And for the AI-based system, it means it's a fixed syntax. So it's a programmed syntax, and that is applied and nothing else. And then we have the gesture language, which is non-verbal, which maybe we also know if we talk about ground workers communicating to the cockpit. This would also mean the AI-based system has actually to monitor the body movements of the end user in order to be able to interpret and act on the gestures of the end user. And then, of course, as we have these different languages and different ways of communicating and interaction, we have to make sure that one of them is actually really present. So it might be the possibility to have a multimodal interaction, not only one, but many of them or all of them. And then we have also the concept of area failure management. So we are talking about failure of the system, but errors are more like design-related areas that also then influence, obviously, operational-related errors. And this is dealt with in the concept paper. What did we do now? Thank you. What did we do now for the rulemaking task? So as Francois already explained the structure of the MPA, the Notice of Proposed Amendment, that we have the interface, so this design considerations here on the left side to the detailed specifications, in our case for human factors, and then on the other side for the initial airworthiness domain only mentioned here and not the air traffic management domain, regulations that are already in place. So we have already existing regulations, and as Francois mentioned, they are mapped on the AMC level and not on the requirement or specifications level. So in our case, we have transposed all the concepts that I've mentioned before in chapters or in AMCs in the rulemaking tasks. So we have an AMC on operational explainability. We have an AMC on human AI teaming. So this is everything about, for example, situation awareness, situation representation. Then we have the interaction modalities, as I mentioned before, that discussion, the communication means, the different ways to communicate, the different languages, and then the possibility of having a multimodal interaction, that's another AMC, and then the area of failure management. And obviously, this is all AI specific. So now in existing regulations, those AI specific AMCs can be pulled, can be tracked from the detailed specification from the for AI-based systems. So for example, in the AMC 251302 that is existed, very well used, there is nothing AI specific and also nothing on operational explainability at the moment. So in this case, what we have developed now can be used and can be pulled. So we have transposed all the components from the concept paper into the NPA. No, that's fine, Guillaume, thank you very much. What do we do in future? As I mentioned before, we have the different AI levels. We have talked about 2A to B already in concept paper issue 2, the human AI teaming concept. And now in issue 03, which is called safeguarded advanced automation, the role of the human has changed a bit. In this case, it is the AI-based system that is achieving the goal. The system situation representation is still, or obviously even more important. And now the important thing in 3A will be that the human end user is alerted by the system in case he or she has to react, interact, intervene, override. There is no active monitoring any longer by the end user, and there has to be obviously still the ability to override. So this is quite new in level 3A, and it has not to be mixed with autonomy. So it doesn't mean this is fully autonomous, because it is still the human end user who is intervening and is safeguarding the system. It is not done entirely by the system alone, and we are still with this. We are compatible with the EU AI Act that was also introduced earlier today. Here we are talking about the limited authority by the end user upon alerting. Thank you. Next slide. So what does this mean in terms of human factors considerations for this level through A? So what we will be dealing with in future. It means for the system, and these are just parts that I mentioned here, the system has to assess the consequence very clearly. It has to detect the degradation of the system, but this it has to do also in level 2, for example, or could do in level 2, but certain things become just simply more important in level 3A. And it is the system that alerts the end user. So the design considerations for the system are here. It is easy to detect, understandable, acknowledgeable. So this, for example, this is the end user has to be able to acknowledge the alert that he really saw the alert, etc. Yes, we have already designed specifications on alerts today. That's nothing new, but there could be considerations because now it is not the end user is not monitoring the system continuously any longer. There could be characteristics, specificities coming up that are different than what we have today. If the system alerts the end user because there is something going on that the system cannot complete by its own, it alerts the end user. And with this, the information that the system has built by building its own situation representation, this information has to be transferred to the human end user that to be able that he or she can build up her or his situation awareness. So all the information that the system deems necessary that the end user has to have in order to intervene, react, etc., has to be transferred so that the end user has all the information that he or she needs. Click, please. Again, the communication is no change really to what we have anticipated earlier on in the concept paper. We have the different ways of communicating back and forward. Now, of course, the communication will only happen if the system has alerted the end user first. So the end user alerts the system alerts the end user. The end user has to react in a certain manner, has to request information, has to request confirmation, etc. Negotiation might be going back and forward. The system has to be able to propose optimal solutions, etc. And there could be communication going on that level. And the next slide. Not slide, sorry. Click, yes. So with this information and communication, so the information that's also gained by communicating with the system back and forward, the end user has to be able to intervene, override, or switch off the system, but not only switch off, intervene, override. Everything has obviously to be able to happen in a timely manner. So there are certain considerations now that are becoming more interesting, more detailed, just simply with the fact that we do not have the active monitoring, but that we have the authority or that the interaction from the end user is happening on an alert of the end user. So this is what we're anticipating at the moment, and it's work ongoing. So we are by far not at the end. And also there will be, I think, a panel discussion tomorrow on this level by Andy. And so still a lot of work happening. And these are just a few elements, a few considerations that we have thought about, that we put on the slide. Not everything is put on the slide, that play a prominent role with some differences to the previous AI levels that we have dealt with until now. And I think I was too fast.
No, that was perfect. Thank you, René.
All right, so changing topics, ethics this time. Okay, so now the same slide, very familiar with it for sure. We are already on the ethics-based assessment. So what did we put together in order to understand a bit ethics when working with AI-based systems in aviation? So our starting point was a bit aligned with what Christine Berg just said in the morning. So actually we are Europeans, we are part of the European system, and we have to respect European rights and human rights in particular. So we also checked a bit in 2018 already what the European Commission was saying to us concerning ethics in AI. And we started right there, yeah, on the Altai. This assessment list gave us a bit of an insight of where to start. At the end of this document that you can just find on the web, just Google Altai European Commission and you find it for sure. at the end of the document, we found out a set of questions, yeah, that really impact us, like understanding and putting in cause what were we doing and how can we solve it, yeah? So I invite you to go to the document and check the questions, because maybe this will give you an insight as a starting point. So we did this exercise a long time ago, but we still see this guidance as a relevant guidance. So of course, and at the moment, we also refer to the AI Act. This is basically our Bible for now, the regulation at a high level that we should really respect and pay attention to. I just put it there, 3 main articles that we think that should be sustained for the AI ethics assessment. Basically, Article 9, Article 10, and Article 14 that Guillaume just mentioned before. So putting all of this together, all what could we do next? Nah? So we checked the regulation. So we don't want to reinvent the wheel here. Nah? So we checked what we had at hand. So basically we went, oh, this question, can this be replied through this regulation? Yeah, okay, then we are fine. We are covered. And this part, this question in particular, in this area, the regulation can reply to this, yes or no? Yes, okay, fine. Then we have also already something. But at the end, we kind of resulted with a set of objectives, which you see on the lower part of the slides, that we decided to draft because it was the things that were not on the regulation and we thought that were important. So you have basically topics like human attachment, personal data privacy, unfair bias, societal impacts, environmental impacts, competency gap, and risk of de-skilling. And then what next? So because we don't do this alone and we always have good stakeholders working on the topics with us, of course, on the industry side, of course, it's very relevant, but also we have the scientific committee and we also have the academic world working with us. We decided to go a bit further. Nah? So we decided to ask directly to the aviation professionals, what do they think about these matters? Do they think that the AI-based systems applied to aviation are ethically responsible? Are we on the right track? Yeah. So we decided to launch a survey. And believe me, this was not a survey like yes, yes, no, no, yes, yes, no, no. Was a big exercise that for sure took more than 1 hour to reply. Yeah. So we wanted to check from the aviation professionals' point of view if they were comfortable with this, if they were trusting it, and will they accept it or not? This was the 3 psychological variables that we took in order to assess the ethical part. Here you see the cases that were on the survey. When I said that it's not a tick, tick, tick box, the survey was really, I would say more than a survey, a working exercise for the professionals that decided to reply to this questionnaire. Why is this so? Because you cannot just go around and say, hey, what is ethics for you? And is this acceptable or not? Because this is a subjective matter, right? And there's 3,400, I'm kidding here, definitions of ethics. And then what we did, we really designed cases, 8 cases applied to aviation that the people could really feel, okay, I'm on this situation in this type of, environment with this type of conditions. How do I see myself towards this? Am I comfortable? Do I trust it? Do I accept it? So there you see the cases that we designed for the survey. So we drafted one on pilot physiological data monitoring through an AI-based system, pilot support in go-around situations through an AI-based system, maintaining aircraft structures, airport allocation of airlines to a terminal, airline crew members' attribution to flights, speech recognition in voice communication, risk of de-skilling, new competencies to develop when liaising or teaming up with an AI-based system, and the tough potato of responsibility and accountability. Right, so who were the people that responded to this survey? We got 231 professionals that replied to our questionnaire. And I mean, you can see a bit who they were there. A bit of a mirror of the aviation world, unfortunately. So 80 male, 20 female, but we try to increase. So yeah, but basically you see that we have here really mature professionals that have relevant experience in the aviation world and somehow are linked to the AI topics. And they feel quite satisfied with their work. Good. So last year, I spoke a bit about the first results that we got, but now we have all of the results already. And this resulted on the edition that you have at the end. So you can find it out also on the EASA website. This is, of course, you can download it and share it. By the way, all of these PowerPoint presentations will also be shared on the EASA website. So don't worry about taking pictures with the mobile. It's not needed. No? Just to say. Good. So back into the results of our study. And voila. What would you say? So on a scale from 1 to 7, where 1 it's not so good, and 7, yeah, all good to go, green to fly. Well, this is basically the main result on an ethical level. We are at 4.4. So this really shows us that we have still a lot of work to do. We have a lot of work in front of us. So I'm going just to show you a bit, not going to the deep results because you have the study and you can really case by case check what was going on. So, but here you see the overall ethical average for all cases together. So we are at 4.4. The list, it's really trust. So we have 4.29, followed by 4.35 for acceptance and 4.58 for comfort. Well, not big deviations here. Yeah. So all of this goes in line, hand in hand. So I just brought here also for you for the 3 variables, psychological variables that we chose. So for comfort, through the cases, just an highlight there. So what you see on a more ethical, responsible mode and list. So it's interesting to pick up case 7, just an highlight on case 7, which is the risk of de-skilling. Yeah. So aviation professionals are very worried about the risk of de-skilling themselves towards the impact of an AI-based system. All right. So we have a lot to do here in terms of warrant that this is not happening. Of course, we have to develop new competencies, reinforce new competencies, give trust and comfort to the professionals. So this is the hot potato for us in terms of ethical impact, big impact. It's on the risk of de-skilling. On the other side, if we pick up case 4, for example, which is airport allocation of airlines to a terminal, they are more or less fine, more into the positive side of the scale, right? 5.17. And then we can analyze it like, oh, why is this so? Well, if you see the cases, you can just from the title see, well, some are more safety related ones, right? Whoa, this is really impacting safety. Then some others not so much, which is actually the case of case 4. So, okay, then we can say the more we are close to safety matters, the more we are facing challenges in terms of ethic-based assessment, which is, it seems to be true. So very quickly, for trust and acceptance, the results go in the same direction. So they all confirm this tendency. Yeah. One thing also that we asked on the survey was, well, do you think that this should be regulated? Is this a matter to really appear on the regulation? And we got these results. So on a very quick basis, we have here for the cases that you see on the screen. You don't see all of the 8 cases. Why? Because some of the cases are already covered by the regulation that we have, so there's no need for that. So we just asked to the cases that were like the futuristic cases that are not yet foreseen on the regulation. And yes, people say, yes, should be regulated. It's a must. We should have guidance. We should have this on the regulation. And the least result here is actually 80.5%, which is quite high. So yeah, what more? So for the guys, so for the professionals that were saying to us, we don't accept it, we don't trust this, we're not comfortable with this. So the people that were pointing themselves on the first part of the scales, like 1, 2, or 3, we decided to ask, but why? Tell us why. What are the reasons behind this non-acceptance? What are the reasons behind non-trust? Yeah. So we got, 2,395 reasons that would not be kind of a show not acceptance. Yeah. We just asked, why not accepting? And very interesting. That's why I invite you to read the study, because in the study in detail, you have the reasons why not. Yeah, and this really, for me, it's the interesting part of the study. So people say, most of them, this is not the overall results as you see there, but most of the people say that they have problems not accepting, considering the AI-based system themselves. So it's not clear for the aviation professionals what the systems are about, how they perform, and if they are mature enough and safe enough. Also, they say that they have concerns about the negative impact that they will suffer when liaising with the AI-based systems. Also, they are very keen to understand what is about the data. How is the data being processed, managed? Who owns the data? How this data will be or not communicated to whom? Yeah. And of course, how is this jeopardizing or putting at risk aviation safety? So the aviation professionals expect from all of us to show that the AI-based systems are transparent, explainable, reliable, and perform according to the standards that they should perform. So this is a message for all of us, I would say. More that I want to share to you today. So professionals want to reinforce these factors that you see. Humans should remain autonomous when making decisions and when overseeing AI-based systems. They should have and maintain the power about this autonomy. They should not feel psychologically uncomfortable, and they should see the AI-based system just as a machine, as a tool. So we should not compromise the ability of humans to perform their jobs well. We should not put at risk the risk of de-skilling, losing their skills, their working skills, and for sure, this should not replace the human role. So with all of this, of course, we brought these ideas into our sphere, in our discussions, and of course, we brought this to the rulemaking exercise group. I have lots of people here that for sure participate on the group. So we have really to have an ethics-based assessment for the AI-based systems. And of course, we are still discussing, we are still putting this together, but we have some news that what we can actually share at the moment that we expect to have in terms of tools to check how ethics is going to be treated. So there's 5 topics that we for sure will have on the regulation at some point. So EU data protection regulation on personal data privacy should be applied. This is nothing new for you, I would say. Then impacts on the AI-based system on the environmental should be also taken into account throughout the cycle of the system, development, deployment, use, and the end of the life cycle of the system. We don't want to have negative impacts on environment. Also, we have to take care about the unfair bias. Bias exists, we know that, we know how to manage it. Of course, we have to mitigate it, to avoid it, but here we have more than just bias, we have unfair bias. Unfair bias, it has to do with not giving equal opportunities to people, having problems in discriminating people, etc., etc. Another thing that we have to take care about, it's the risk of creating attachment, addictive behavior, or eventually manipulating the end user's behavior. All of this is new for us. It's more into the psychological part. How the professionals can be impacted in terms of attachment, dependence on these AI-based systems. Over-reliance is linked to this, and it's an important topic also. And of course, we expect the AI-based systems do not present social unacceptable characteristics. This is also to be discussed and to be defined. But how can we do that? Yeah, because all of this is like the new kid on the block, like ethics in AI for aviation. So we are discussing the concept, and we want to do, together with all of the stakeholders, a first checklist, okay? So we consider and we listen well our stakeholders and our partners, and we want to put together a checklist. Of course, this enables what? For you, of course, to understand if this first step, this first analysis makes sense to your case. Yes? As Guillaume was saying in the morning, this doesn't apply to all of the cases, right? So with this tool, you will analyze if it's meaningful for you, if it applies to your case. And of course, the checklist should be a practical tool and clear tool, very well defined. So this will give you an idea of what you should consider in the future and what you should not consider. All right, what more? Just to close. I don't know, is the timing right or am I rushing? Okay. So more things, of course, that comes also from the study and the discussions of with our stakeholders. So professionals want us to warrant that they should maintain their competencies, or the competence should be developed and reinforced. So, and this has to do with the risk of de-skilling that I was just reinforcing before, okay? So again, we have to gain experience. Professionals are not ready to do it now. We have to gain experience. Professionals have to gain experience with the AI-based systems. They have to pass through this phase. And of course, we have to also consider that we have to keep manual practice. If something goes wrong, or if all goes wrong, or we have another COVID or something like that, knock on wood, we have to for sure have manual practice ongoing on a well basis. And it's not just to know, oh yeah, this is done like that. This is done like that on the right timing, not like thinking first and acting. You know what I mean? We cannot lose efficiency. All right. So of course, a good training process and path should be put in place to have also this all covered. Other areas that we should discuss with you, it has to do also with having to draw a line between responsibility, accountability, between these two entities, right? The human and the machine, okay? It's very tough when we analyze the results of the study, in particular for the case of maintenance. So the experts are not really keen to take responsibility if the analysis is done by a system, yeah? And this really shows us that we really have to take care about responsibility and accountability, where to draft, where to put this borderline, and who is responsible for what, who will take account, the accountability for what. And this really, it's really important when we have this shared responsibility. So René was just telling you, hey, we are here defining collaboration, cooperation, yeah? So we are referring to the level 2A and 2B. So the more we kind of introduce this linkage of relationship, sorry for the word, maybe it's not the best word, relationship with the machine, but the more we get into the machine or interact with the machine, the more we have, to take care about this, all right? So lots to do. Of course, I also referred the GDPR part and the unbiased part. So we, of course, don't want to have unfair bias. We have to identify, monitor, and eliminate this part also. Good. So closing down, what are the next steps now? So we continue to discuss, we continue to define, and we will for sure revert to you. We want, of course, this also to be transferred for the concept paper issue 3. We expect that. And we want at a certain point also to understand the opinions of the general public concerning ethics in AI for aviation. And that's it from my side. Thank you for your attention. Thank you for the guys online still with us. And I think we go. And I think we go for Q&A. So the three of us are available for your questions. Thank you.
Okay, so maybe I'm going to distribute the questions from here. Or do you want to manage the session from here, Ines, so I can manage the Slido from there? It's up to you. Just not to one each side. So you can. Yeah.
We did it. By the way, of course, you can ask your questions in the room. We have also microphones for you. Just, say to us that you want to put a question. Okay, so can you please okay, sorry.
This one is
This one is not for me.
we're working on it. Marisa and everyone is working on the cooling of the room as much as practicable. So we saw your comment.
All
Thank
right.
you for that.
So would EASA accept tools like ChatGPT, Gemini, etc. for design development, or EASA will only accept in-house proprietary like LLM, but must be certified by EASA? So this is more for Francois, maybe, right?
This is a very good question. I think it is much too early to have a definitive answer to the question. Obviously, it will depend on the safety criticality of the application. In the context of the tool usage that was mentioned by Guillaume this morning, this is probably something that we have to investigate. When it will come to safety critical applications, I would just mention some things that I discussed yesterday evening during the reception. If we look, for example, at ChatGPT, we, from release to release, we obviously observe very different behaviors. So if we consider a tool that would be used during tens of years, the question about managing the sequence of versions of such a tool could be problematic, as we cannot really anticipate what will be the features of such a tool version after version. Probably this is something that will continue to evolve year after year, but I think this is also something that we have to consider. Also, in our views, all these general purpose LLMs will need some adaptations. With example, some RAG techniques or graph RAGs techniques in order to make them effective for the different aviation domains. So these are all the things that we have to consider when approving such LLMs.
No, I think you said the most, Francois. Maybe just to jump also on the other part of the question, which is must a LLM be certified by EASA and will only in-house proprietary be accepted? Actually, no. We have no restriction limitation, except what Francois was saying. It will depend on the usage. It will depend on the criticality. It will depend are the output verified or not by human or process activities. So we are in this logic. You will see a lot more about that tomorrow in a panel of discussion. You will see also a presentation from my colleague Maxime on what we anticipate today in terms of concept of filtering tools. So I didn't go in details on that. you will see a bit more. But the idea is really not to restrict anything from the start, but really carefully weight the usage one by one. So it could be ChatGPT, and we have also an IPC presentation tomorrow on the Lufthansa with the Lufthansa Group team that you will see goes on the usage of I would say ChatGPT-like LLMs. So it's open, but still needs to be bounded. I would say that's the main message here. Yeah, thank you.
All right. Well, the following one is for you, Guillaume. Would the EASA accept? Good morning from UK. Good morning.
Good morning.
Okay, so is autonomy going to be forbidden by the UI Act? So from the slides about level 3, it seems like it is. Yes or no?
It is our understanding, and to be very, very clear and transparent, even at level 3B, which we call advanced automation, not autonomy, we already had a number of discussions with our colleagues at the EU Commission in the interpretation of the Article 14. So already at advanced automation, at the maximum level, we see practicable innovation today. There are questions. So definitely what is called autonomy and defined as autonomy in the AI roadmap, it's defined as a system capable of setting its own goals and or its own usage domain. For us, it's really science fiction for the aviation domain. Yeah. So, and clearly for the Article 14. This is where we don't have a crystal ball of what comes next, which technology will help us going further. But for now, that's the limit we see. And we see it as a indeed forbidden element, and we don't want to open it, let's say, unreasonably for now in the AI roadmap, in the current one.
Yeah.
And we
so,
had, I think,
following.
Good morning from the UK, I think.
Yes, but
yeah?
our colleague from the UK is rating down on the list. So, but yeah, well, let's go for that. So he's just asking us or her, what low complexity ML system was certified by us, by EASA, Guillaume? Can you give the example?
Oh, yes. I was mentioning on the slide, it's about the runway overrun alerting system. We had a case of work with our colleagues from Transport Canada on one of the case. I mean, there is a mandate in preparation, so people are more and more, I would say, preparing updates to this type of systems. And we had a case where a machine learning model would replace a previously used model. And we had indeed a lot of discussion on the notion of dimensionality of the data sets, let's say, and data input and complexity of the model. And we went to a pretty easy case, I would say, of using the concept paper, and that was the type of system that we started with. Yeah.
All right. I hope I didn't miss any of the questions before. So the following is, what is the definition of AI operational tools and how differentiating them from products that needed approval or certification?
Maybe I will take this one as well because it's on one part that I was presenting. Again, tomorrow you will have a bit more insight in this discussion on operational tools because we have a panel of discussion with also industry partners showing their expectation. A very simple definition is whatever is not an AI-based system proposed under a product approval or an equipment conformity assessment will directly go on the side of AI-based systems used as a tool operationally, right? After the word operational, we stick it always in our presentation and in the wording we anticipate to the notion of approved organizations. We don't want to open the floor to anything AI-based that could be used in aviation. I mean, project management tools, etc., will clearly not be on the table or on the scope that we target. We target really tools that are used under a scope of an approved organization for this approved scope. And this is all things you will see a lot more in details tomorrow. So I don't hold the floor too long for this one.
Yeah. So the following one, it's for Andrew. So for human AI teaming, how can pilot training balance trust and vigilance with non-deterministic AI to prevent over-reliance during non-nominal events? Andy?
Well, Renee can jump in too if she's still listening and online, but that's quite a question. Pilot training will continue to do what pilot training does, which is to focus on non-nominal events. So I've not heard of off-nominal. I'm presuming that's non-nominal. So they trained for non-nominal events, and that training will continue. So in ATM, we have what's called continuation training, and that's the same thing as well. So there's a constant stream of training that's based on focusing pilots' abilities, controllers' abilities on dealing with situations that they're not necessarily ever going to experience. The introduction of AI, in theory, will bring about some additional focus of a system that was there to aid them. But the purpose of continuation training isn't to be replaced by AI, it's to continue that training. So I don't see AI replacing continuation training. I see it as an additional tool, a tool that controllers currently have access to half a dozen of. Pilots currently have highly automated systems. This will just be another tool that they're going to use in the cockpit or on the ground. So continuation training will continue, and it will continue to support pilots and controllers in developing responses to non-nominal situations.
Thank you. All right. Fear, regarding the fear of de-skilling, how was this addressed when the autopilot was introduced? This fear should not prevent meaningful improvements with AI. Yes, fine. The thing is that we just listen to the professionals, and that's the feeling at the moment towards these things. So
if I may, because that's back to conventional aviation where I meet. And actually, you know, we have noticed over the last 30 years that autopilot had an impact on basic flying skills of aircraft, of pilot. And what we've seen today, and we have had recent accidents in the past, which showed really that pilots were relying extensively on automation, and went back to manual flying, it was a problem. And that's why most of the operators, most of the airlines are getting back, you know, their pilots to manual flying with some mandatory training in flying manual mode, because we have, some of them have lost the capability. So, you know, it shows that what is addressed today is fully relevant. It's not something that is completely outside the scope. It's a lesson almost from the past that we have paid, and we should take into account into the future. So that's really nailing the point.
Thank you. Yeah, of course. I mean, we can have super duper systems that we know that are functioning well, and we are super fans of these technologies. But the thing is that if the people that are using our super duper systems are not trusting the systems and they don't feel like using it, then we'll have a trouble. So that's why we have to work a lot on gaining trust and gaining the professionals. So explainability here, it's key. Good. So we will have ATC AI and cockpit AI. They may negotiate about solutions, like, for example, in the case of conflict. Which part of EASA regulations deal with AI negotiations? Whoa, this is tough. Guillaume?
I will give a go at it, but it's probably not a final answer. I think we start looking at this aspect more when we go to level 3 of AI, because we will have, again, less human. Today, operations are really relying on the human. Of course, there is automation, but it's relying. So when you have a communication, it can be automated by certain means, okay, but still you have a pilot, you have an ATCO. In the case where we think, again, a bit more futuristic, drones managed by U-Space and so on, there will be surely kind of a machine-to-machine communication, which will not be directly expressed necessarily to a set of humans, and maybe no humans actually in the loop. So this is where we will have to think, maybe not AI negotiation as a topic, but more like a machine-to-machine consideration could be a part of the framework on the level 3. But this is something I would say we have not really worked on or progressed on so far. It was one line in the scientific committee framework from this year, but it's not something we've engaged too much. So I would say a very interesting topic to keep on board.
Yeah. So when saying freezing the models for production deployment, does this apply to the training data as well? And if not, is there liability on the training data? Maybe Francois, you can help here.
Yes, I can start by answering the first question, and probably I will need Guillaume for the second part of the question. So in the process, there are different steps when learning. One of them is data management, and at the end of the data management process, there is this allocation of a data set into 3 different data sets, one of them being the training data set. So even if this training data set can evolve during the learning phase, at the end of the learning phase, when the model is being frozen, at that time there is no evolution of this training data set. So this training data set is, I would say, by nature frozen as well. Now this does not prevent preparing the next learning phases of for the same model. For example, in the case of retraining the model once it has been in operation. So this does not prevent continuing the data collection process and preparing the future learning with some new training data set. But I think that this is more a question about the development life cycle and the iterative development life cycle rather than this notion of freezing of the model.
Yeah, I will take then the second part of the question. I think there is not a specific liability on the training data based on what all François just described, but the training data are part of the development assurance process, let's say. So the learning assurance will leverage the training data as an artifact, as a life cycle data. In some cases of modulation of proportionality by assurance level, it will not even be a life cycle data, like in a DAL-D equivalent today, AL5 equivalent, we don't anticipate the training data to be a life cycle. So there is no specific liability. It's part of the life cycle data. It will be required for certain assurance level. And of course, at the end of the day, because it's part of the assurance process, it's influencing the performance, the intended function, etc. So from after, if we go to what Ines was explaining, responsibility, accountability, liability, to make it very simple, we don't deal with liability. It's more like, I would say, a national law scheme, court of justice, etc. We deal more with responsibility as a first factor, and that's where it will start to be very important in level 3 systems in particular, because the responsibility will not be anymore on the end user, but probably a shared. Now, does it mean we consider a system can be responsible? No, not at all. We really try by all means in everything we do to not personify the system. So if there is someone behind the system, meaning first there will be a developer, a manufacturer, a deployer, this is the place where we have to look for a notion of responsibility that will drive after the accountability, which drives the liability. And I would say this is the part of the work we've not yet completely defined, because we are working on it in the level 3, because level 1 and 2 doesn't raise the same question. In level 1 and 2, we stopped the game saying level even 2B, which is the most advanced automation we can think of at level 2, cannot be so advanced that it will take a part of the responsibility of the end user. So it has to be extremely well bounded. And we are fine to go with level 1 and 2 with this consideration. For level 3, it's a very different game. So we'll have to look at, again, not liability, but more responsibility connecting to accountability for level 3, overall for the overall system, not only for the training data.
Thank you. So talking about level 3. So in 3A, being ready to interfere at any time without any contextual info, no active monitoring. Might be a cognitive workload heavier than active monitoring. Well, this is a mystery, no? We don't know, probably. We are not there yet, so I don't have an answer for this. What is important for us to know is that we should keep manual practice, right? So at least we have the competencies that enable us to understand the situation. So we would have contextual information. And on the other side, we have to know very well the AI-based system and what is behind the decisions that the AI-based system will make. So if this is more workloads, cognitive workloads, I don't know. René, tell me. Do you know?
Yes. No, thank you. Thank you. You said very well. Of course, we do not know yet, but yes, we are anticipating it to be a challenge a bit, because that's what I also showed in my slide about 3A. So this is where we said we have to transfer all the information from the system to the human, and we have to consider that the human has to have the information, being able to intervene in a timely manner. So indeed, this is one of the human factors considerations we are thinking about and we have to think about. But yes, we don't know yet. Will it be heavier than active monitoring? It will be different, and we have to consider it in the design of the AI-based system and the information provision from the system to the human.
Renee, can I just jump in? Sorry, it's Andy speaking. As the question stated, that's exactly correct. Yes. Somebody being expected to intervene without all the contextual information will have a heavy cognitive workload. The point is not to provide, as we'd say in rugby, a hospital pass. So what you don't want is to pass the ball to a controller or a pilot when there's nowhere left to go. And the whole point of being able to consider this at this point is to design the system so that it's not dropping the end user in the mess as and when something goes wrong. There are other things in air traffic control. You can put flow restrictions on. You can limit the flow of air traffic in the cockpit. You can reduce the operational tempo by putting yourself into a holding pattern and so on. So we don't expect additional cognitive workload. What we do expect is the provision of that contextual information before you're then handing the ball back to the operational member of staff that's expected to deal with it. Okay. Thanks, Renee.
Thank you. I know that we are on more or less end of our time, but maybe I will take, no? Oh, okay. Fine, we gain time. Good, so we continue. So regardless the risk impact of AI application, do we require that the user is informed that the system is containing AI? Yeah, I would say so. Should be informed that there is an AI system.
There is in the concept paper a line. I'm just trying to think back if it's on the human factor side or if it's on the ethics side, by the way. But yeah, we have one of these lines, I think, was in the Altai.
Yes.
And in the AI Act, there is still something about making clear that someone is interacting with an AI-based system.
That we should
so
be
we will
informed.
cascade this requirement for
Yes.
sure. Yes.
Okay, if the human is to maintain autonomy on the decision over AI, what if the human is worse placed to make that decision over AI? Is this adding risk? Andrew, maybe this is more for you?
I think, to be honest, that's the world that we live in. That's today. This is where we are. As a youth, I had to read accident statistics. And in my region in the UK, 400 people per month were killed or seriously injured on the road. So it's not like introducing AI to driving systems is going to make that much worse, to be perfectly honest. So we are worse placed to make a great deal of decisions. It depends on the sophistication of the AI systems that we're introducing and the role that we expect them to perform. So within that, all I'd go back is saying within the operational description that Francois talked about yesterday and we'll talk about again at some point is we'd expect the context and the use of the AI to be bounded. And we'd expect to understand what the role of the human is within that system. So it will add risk. It will be the existing risk that we have. And the idea is that the AI system will mitigate some of that risk. So I can't say more than that, I don't think.
Thank you. Next one. What are the safety risk implications for DOAs and POAs that could be anticipated when utilizing or using AI for designing and production purposes? Guillaume, maybe this is more for you.
I think I will connect directly this question to, it went down, to the case of, again, trustworthy AI tools and the possible approval of certain tools. It's exactly in this remit. DOAs, POAs will be approved organizations. If they use a tool that presents a risk and is not, first is in the scope of the approved organization, present a risk without being fully verified, we fall back into this risk implication. So the safety risk, what we try to do, and again, you will see much more tomorrow in the panel of discussion, is to push as much as possible down the path, everything that is about entering the AI trustworthiness framework. So we stay at the level of the current regulations. We will see how much is needed, I would say domain by domain. A DOA might be completely differently managed than a POA from a tool perspective. That's totally open. And we try to stay at the DOA POA level without the need to consider anything about AI and trustworthy AI, as long as the tool does not need and require a certain qualification. So this is what is anticipated. Then the safety risk implication will be verified per the existing process at the level of the AI trustworthiness framework if it applies. And again, that's the filtering logic.
Thank you. So I'm just doing a small break here, and I will ask you if you have questions here in the room. Marisa can help you. So questions or comments are welcome. Yes.
Hi, I have a question towards possible gray areas where we are not at level 3, and for example, any application of AI to help in quality inspections, for example, where officially the human is responsible and accountable in some sense in organization. Still we have but the scaling and all the benefits might only come if we have a high level of automation at some point in the future. Even if we develop everything according to the standards, the systems are probabilistic. So there is a kind of I don't think we can push the limit of errors below certain thresholds, maybe and still be economically viable. So if in the best of the cases, everything works out, but if still organization is in place, everything is in place, and some error might occur, so who would be responsible, or what do you think about responsibility in this case where everything has been done to the best possible level? The system makes a mistake, the human trusts the system based on the trustworthiness, but still something occurs. Are there any thoughts on that?
Thank you.
Yes, thanks for the question, Sergey. I think it's connected again to from what you described to the tools usage. So again, here we are very careful. We will and we plan to use the same logic of level 1, level 2, level 3. We need to see if it maps completely, because we could have a number of use cases coming, and as you say, a bit in the gray area in terms of classification, which will push probably a bit away from what we've done with all our colleagues here, but in particular with the human factors related to embedded systems and or equipment qualification. So I take really this careful thinking. Now, if we can put level 1, level 2, level 3, I would say we will be in the same area. Level 1, level 2, we will rely on the human present in the loop of operation to deal with that completely. We will not change the responsibility. After, it doesn't mean responsibility is solely with the end user. It's still as usual, business as usual, I would say, in our domain. In level 3, if indeed we are relying on an automated outcome of a tool without specific verification and really relying on it, then, as you say, the level of performance and the target performance will be absolutely necessary to be negotiated at the time of approving this tool. And sometimes it could be with a safety benefit in mind. It could be better to have the tool than not to have the tool, and then you can deal with that through this angle of attack. If it's not, probably it will be a huge negotiation at that time. But that means also, and just to put everyone at ease, if we only, I would say, approve level 3 tools, I don't think we will have a lot of discussions in the first day, in the early days. We see a wave of tools coming, but probably from those, a lot will fall on the side of either no qualification needed or safety benefit or. And by this mechanism, we anticipate that the discussion should be actually on specific tools. Now, if some tools are really used in a very automated way, we want it to be managed properly. And we see the AI trustworthiness framework as a way to deal with that with the intended function. And we will see with experience, to be honest. It's a very preliminary anticipation here.
Any other question? Yes? Questions or comments? Otherwise, I will go to Slido again. All right. A request to summarize the delta or the difference between concept paper 2 and concept paper 3.
So I propose to start with elements for the AI assurance. So obviously there will be what is coming with the new technologies that are on top of supervised learning and unsupervised learning. So these are new elements that will come into the concept paper issue 3. Now, if we look at what was the scope of the concept paper issue 2, so supervised learning mainly, we will, in the issue 3, take the benefit of what happened in the last 2 years, meaning the progress that we have made with the standardization group and the recent development of the draft ED 2324, to reflect these aspects onto the objectives of the concept paper. We will also take advantage of the recent certifications that took place in order to leverage some of the objectives with what we learned from these certifications. I will just provide you with one example. In the current issue 2 of the concept paper, there is a specific section that is named Development and Post-ops Explainability. With the working group, we think there have been developments putting some of these aspects under the notion of verification of verification. And it is possible that this would be reflected into the concept paper issue 3. But there are many different other aspects, like, for example, the progress that was made with the safety assessment and the 8 mocks that we have in the issue 2 that probably will be reshuffled completely to better align with the standard. These are few examples.
Yeah, I will just complement, thanks François, with 2 things. We will also take benefit of the rulemaking group exercise and the fact to translate the concept paper issue 2 in a rulemaking set of AMCGM. Of course, has streamlined a lot of considerations on certain wordings, certain objectives not necessary, etc. This will be reflected also, for sure. What I wanted to add is, of course, the level 3 of AI, as was presented already, will be part of it. So we expect with the issue 3 to be at the, let's say, the final stage of opening the floor to every anticipation on the current scope of the roadmap 2.0. To be very clear, after it could be the last revision of the concept paper if everything goes well, but if a lot of novelty comes, of course, we will have to anticipate the concept paper in the future. But so far, we are trying to finalize the current scope of the roadmap 2.0 in the concept paper 3. Yeah.
So next one, do training systems or simulators, etc., fall under EASA high-risk remit? I don't know this.
Yeah, maybe I will take this one. It's it's a complex topic because it could be either connected to the tooling notion, using a simulator as an element for a development of a system. That will be exactly falling on the scope of do we really need a qualification of it, or do we verify all the outputs otherwise, etc. So I think that would be one way of thinking. Now, if it's simulation, and I don't know an example right now involving AI, but that is used within a running embedded or at least deployed equipment and system, I don't think we've met something like this yet, so it could be under the high-risk remit. But I don't think simulators overall today. Let's take just the reference point we have today for traditional software system development assurance. We already have simulation environments, right, that are used. They are never qualified as a tool, etc. So I don't think we will change the world on that side. I'm just thinking because the question pushes a bit to the logic that maybe a simulator, I don't know, for whatever reason, could be embedded in an high-risk system. That's maybe another case. But if it's a simulator used for the development or really as a tooling in the development, it will be quite simply used or managed as we do for classical systems today. Yeah.
Thank you.
You're welcome.
So when it comes to level 3B, who will be accountable for the AI decisions? Not the human operator for sure.
Yeah, I think we are back to the same question. So accountable, I don't know. Responsible, we have to determine. And what we consider is that level 3 raises the question. We cannot certify or approve a system that will be an AI-based system that would be level 3 or 3B without considering this responsibility scheme. After what form it will take, what exactly guidance we can put on the table, we will never rule on a case by case. This is the person responsible, because at the end of the day, it makes no sense.
Yeah.
Again, the accountability liability will make its way anyway. But from the responsibility, from an approval perspective, I think we need to clarify a number of things, having at least a kind of a document, life cycle data, maybe that is dedicated to that, saying what is anticipated by the manufacturer or the deployer in terms of responsibility. That's the logic that the AI Act is taking. We should translate it in the aviation. But I don't have a final answer as well. It's quite a tough topic. Yeah.
Yeah. Just to add on that, I don't think the aviation sector will come up with the solution. It will be probably the insurance sector. I'm not kidding, you know. Who is going to take the responsibility and who is going? So is it the manufacturer? So it's the insurance will probably pave the way of a lot of things on that.
So next one, will there be a standardization of the risk impact assessment given the various methods available? Guillaume, maybe you? François?
No, I can take it. No, there is not a standardization of the risk impact assessment anticipated, because we have risk impact assessment or safety assessment or safety support assessment methodology that are already in place. So this we don't want to touch and change and standardize. That's not the intent. But you saw in the presentation from François a generic block on risk assessment, which could serve the purpose of, again, possibly this notion of tools, if deployed in a domain regulation where there is no specific risk assessment from a system development perspective. And this is where we could complement it and propose somehow a generic method to evaluate a risk in a case where there is no such thing in place. If there is something in place, no standardization is anticipated there, not at all.
So next one, how should ATC AI be involved in occurrences investigation, both as investigator and as potential cause of the error? François, maybe for you. Do you want to reply? This is.
I would rely on you for this one.
Sorry, Francois been put on the spot, but I'll jump in.
Okay.
I did 6 years work with the ATC incident investigation.
Okay.
The process and the requirements for an investigation are actually laid down in regulation, what it should contain and what information should be reported, and in fact, how it should be reported. So how could you use AI within the framework of investigation? Well, it's all standard reports. So you have to do an analysis of the voice tapes, you have to do an analysis of the radar data, and you have to interview the controller. Interviewing the controller will not be particularly easy if you're just using AI, I suspect. And then the third part is you have to write to the airline and get their perspective of what happened and why it took place. So I don't think there's a great deal, or there's not a huge role within the scope of incident investigation, because it's not particularly complicated. It's just a process. Could you speed it up? Maybe you could by going and finding the relevant track data or the relevant voice tapes. But again, that's all digitized now anyway. So if you've had a loss of separation, the whole world in the ops room knows about it. So you know what the time it occurred, and you go back maybe 10, 15 minutes beforehand to find out what happened. As a potential cause of error, well, this, I think, is kind of the interesting one. And this is where we get into Francois' development assurance. And it's where we also get into this concept of, when we're looking for explainability, it's not just the end user that's interested in explainability. It's the development explainability as well, is why an AI has made a specific decision and what the outcomes of that decision would be. So this is the bit where I think if we're interested really in understanding how AI has contributed to the loss of separation, then it's this development explainability that's going to be crucial in kind of picking it up and looking at it. So I hope that's answering.
Can I just say
Sure.
something as well, please?
Sure.
In my role as safety risk manager for ATM and dealing with occurrences, it is all laid down in Regulation 376. Of course, not the AI, the role of artificial intelligence, however, potential cause of errors. So for me, there is no, for the moment, no change in how to report your occurrences and how to report the cause of an error. You can do that, and that's how it's done today in line with 376. But of course, there might be an impact, and we have to consider that on the taxonomy that we have at the moment in ECAS 2. So because there is nothing specifically on artificial intelligence, the question is then, is it needed, or can the cause also be covered with the taxonomy that we have today? So this has to be considered in existing regulations as well. I don't know about the investigator part. I can just talk about the occurrence, cause of error and reporting. Thank you.
Thank you. I guess that the other one is for you. Yes, of course.
Now it's on. So what I'm thinking is, if you had some form of AI, I'm thinking ahead, in the control for the engine per se, or for the aircraft, you would certainly want to be able to trace back why it did what it did. So that might impact the traceability that you would find in the control. So I think as we think about these applications and putting it in the FADEC, or putting it in the control for the aircraft, we want to think about what's going to be in the black box. That's not the voice recorder, but it's the other one, the data recorder. So that was all.
Thank you. Thanks so much. Of course, you can always jump in, okay? I'm following the slide, but you know that we have here Marisa that can help you. Right, so another one maybe for you, René. At level 3A, how is the human and end user alerted? Is it by a machine learning based function, or with safety critical risks and independent non-ML?
Well, that's a good question. I wonder if maybe François is the one to answer if we're talking about machine learning based functions.
Can I defer? Sorry, René, it's Andy jumping in again.
Yeah.
Can we defer this until the presentation tomorrow, in fact, when we talk about 3A systems and end user alerting? So the idea is not to have a dog attached to a workstation that bites the controller or the pilot. But ultimately, it's about what your system is and what defines or determines a timely alert. But we've got an exercise on that tomorrow, and we'd be interested in your input and your thoughts, basically.
Cool.
Okay. So ethics and AI, will the results be turned into MOX rules, like for AI and ML and machine learning, and when? So yeah, we'll expect to have the same, like the paths that we do for AI assurance and the path that we do for AI teaming or human factors will be the same path that we do for ethics. Yes, so it works on the 3 dimensions at the same mode. So yes, you'll have regulations. When? Maybe this we don't know yet. All right. So regarding the AI tools which may or may not need certification and approval, depends on risk. What does this risk assessment means? Is this in line with the safety assessment? I would say so. Guillaume?
Yes. Yeah, that's aligned with the concept of a safety assessment. So the idea is to identify a risk with its severity and probability, and based on these 2 essential parameters, to have a certain, I would say, canvas grid of reading based on a certain hazard, to allocate it and connect it to what we call an assurance level. That's the concept. And again, it will be domain by domain and surely managed differently on some, I would say, domains than others. But we offer with this block, again, I'm referring to the François presentation, this generic block is exactly what I was just describing, ready to use, but not necessarily adapted to everyone. So we will have a case-by-case connection.
Thank you. Next one. Should decisions made or proposed by an AI-based systems be recorded in an aircraft black boxes or recorded for accident analysis?
Okay, I start. Okay, thank you for the question. So there are already some objectives in the concept paper. Before going to the notion of recording, I would like to just mention the notion of monitoring that will be requested. So the monitoring of the input data, checking that these data are within the designed, the operational design domain. This is one element that we have in the concept paper. Another element is the monitoring of the confidence score of the predictions of the model. These are two elements that we have identified as necessary. These elements will then be recorded in order to be used in the case of incident and accident investigation. Of course, all these aspects will need to be proportionate. And at the moment, we have decided that for DAL-D or AL5, these requirements on the monitoring and the recording will not be requested. So meaning that probably this would take place at the level of DAL-C applications.
Okay, we are almost closing, so I'm taking 2 more questions, so let's go for that. So about AI assurance, can you please elaborate on what you mean by interfacing the AMCs, acceptable means of compliance, between new AMCs and existing AMCs? Guillaume? François?
Okay. I will take the example of the ATM&S domain that probably you noticed I know probably much better than initial airworthiness. So I was referring to, if we take, for example, the development assurance in the 373 regulation, under the safety assessment or safety support assessment, depending on what is the type of operations being delivered by the service provider. Under these requirements, there are already a set of AMCs available. And interfacing means that we will revisit these AMCs in order to check if they need to be complemented by direct calls to the AMCs of the DS. So this is what we have in mind. For example, there will be AMC 1 to requirement 205. And in the text of this AMC, there will be a call to AMC 2 of the requirement on the development, on the learning assurance in the DS. So this is typically the way we will interface between the different regulations at the level of the AMCs.
Okay. I just heard that we have 3,400 questions. Kidding, but a lot. So we will not manage to reply to all. We still have another day, so let's see if the workshops will bring also added value to the questions. And then if you really are not, if you don't find your reply towards the works that we're having today and tomorrow, we will get back to you, hopefully. Yeah. So just to finalize, if during an online pilot training, AI sees the trainee pilot in this case, weaknesses, and gives suggestions to study, learn better, will it be not mandatory for the pilot? Andrew?
Would it be not mandatory? In other words, would it be mandatory? This is entirely down to the training organization and how they implement the system and what its training regime is. So it's not EASA's place at the moment to mandate the use of AI systems. I know there was a conference last year in Greece that René organized actually, where one of these systems was presented. And with all things, they used a large language model, and I think they used cameras to study pilot behavior, and then used AI to analyze that behavior and to see whether it was the pilot was demonstrating best practice and other things. The outcome was ultimately that the AI system wasn't as good as we'd hoped. And with all things, when writing reports, went through a system of producing hallucinations as well. So there's nothing to prevent it happening. But again, the systems need to be ready and properly validated as well. I think David wants to come in as well.
No,
Thank
yeah,
you.
It's also linked to regulation activity in training environment like evidence-based training, which is something, and that will be framed in this kind of regulation also. But first, the system needs to probably function properly.
Thank you. Thank you for your questions. Over to you, Janet.
Maybe Janet, if you don't mind, I will just take one that I see was a recurrent question regarding the mandate by EASA on using AI. Clearly, we don't push for that in any way. It's more coming from the other side. You propose as industry tools, systems, equipment, etc. We take them and we augment our understanding experience. As you could see, we don't have an intended mandate to specifically mandate AI in a certain context, just to make it clear. Yeah, sorry for that, Janet, back to you.
Thanks, Guillaume, and thanks to everybody else from the project team who answered a lot of questions there in a short time, must be said. Okay, we're going to go straight now into the next session. So first up, we have one of two flash talks. We're going to do the two flash talks together, and then we might have time for a couple of short questions, but it won't be much just because we haven't allocated a lot for this. So first up now is from the FAA. Here next to me is Mazdak Haubi, who is the representative to the EU for the FAA. So, okay.
Good afternoon. Everyone hear me well? Well, good afternoon, Mazdak Haubi. I'm the FAA Senior Representative to the EU. Here on behalf of Dr. Trong Pham. Unfortunately, he was unable to travel to Cologne this week, so he's asked me to step in. I'm based out of Brussels, so it was a much shorter trip for me to partake. So I know I'm the first speaker after lunch. So to engage your mindset for my talk, I'll start with a quick thought experiment. Imagine you're boarding you're going on a holiday tomorrow with your family and loved ones, and you're walking down the jet bridge, and you see a big sign. I mean, normally we don't have these signs, but let's just, for this experiment, have this sign. You see a sign that says, "This aircraft is certified with artificial intelligence on board." Would you feel safer or nervous? See, if you're hesitant, that's the whole reason we're here today. That hesitation is exactly why we want to make sure AI enhances aviation safety, never undermines it. So as any good authority, we have our quick disclaimer. So this presentation comes from an engineering standpoint. Our goal is to clarify what AI can and cannot do in aviation. At the FAA, our objective is simple, but non-negotiable. AI must enhance safety and not introduce unacceptable, unpredictable risk. This is our agenda. So how do we get here? Aviation had its ChatGPT moment. Oh, is that okay? Aviation had its ChatGPT moment when Boeing introduced the MQ-28 Ghost Bat in Australia in 2019, fully autonomous. Public attention on AI in aviation has grown rapidly since then. That moment sparked global interest and quickly created pressure on regulators like the FAA and EASA to prepare for AI within the certification frameworks. We at the FAA see AI not as hype, but as a real technology. The challenge is to integrate it responsibly into aviation's disciplined safety culture. Conversations around AI in aviation really began in 2020. EASA moved first, publishing the AI roadmap in 2020, followed by the technical guidance in 2021, and then later roadmap 2.0 in 2023 with the technical guidance of that in 2023. The FAA introduced our roadmap in 2024, last year, focused specifically on AI software on board aircraft. So again, you're going to hear this theme throughout my presentation. The FAA is really looking at this from a bottom-up approach. Our roadmap is anchored in the following guidelines and principles. Work within aviation's proven ecosystem. Avoid personification. AI is not crew. Keep the focus on safety and take incremental approach. First and foremost, the FAA regulates safety only. Broader ethical and societal issues, while important, are outside our current mandate. And Congress the U.S. Congress sets the FAA mandate. So I'm not making those decisions. That clarity helps us stay focused on what we do best, making sure AI onboard aircraft does not compromise safety. AI is treated as an engineering component, not as an intelligent being or a crew member. Accountability must always remain with the designers, operators, and the applicants, a lot of you here, never with the AI system itself. We make critical distinction between learned AI and learning AI. Learned AI is fixed once trained and verified. It's static when it's on the aircraft. Learning AI, on the other hand, it continues to change after deployment. That creates major certification challenges because the behavior is not predictable. Our current roadmap does not allow continuous learning AI onboard aircraft because aviation demands predictability. And I said currently. It's a living document that may change in the future. Applicants must demonstrate compliance at 3 levels: the item, the system, and the aircraft. This tiered approach mirrors how we already certify avionics and ensure AI is held to the same rigorous standards. Our guiding principles are to keep the focus on safety, avoid personification, and use as much of the existing regulatory framework as possible. This allows us to build confidence incrementally without reinventing the wheel. FAA is investing in supporting research, for example, methods of compliance for AI and data analytics for safety assurance with applicants. And we're doing this in partnership with EASA, industry, and other stakeholders to ensure global harmonization. The FAA roadmap is pragmatic. It anchors AI firmly in our safety framework, sets clear boundaries on what is acceptable, and ensures applicants know exactly what is expected to achieve certification. Predictability. This diagram shows how the FAA treats AI, specifically machine learning, within the certification framework. The focus is at the item level, where the AI software itself is developed, tested, and verified before moving to the system integration and aircraft and into the aircraft system. On the left, you'll see the development choices available. For example, how the model is built, trained, configured. Machine learning introduces uncertainty because the model is learning rather than fully pre-programmed. So we have to control how it's developed and verified. Data is used to generate and train the model, but critical questions is, does the trained model meet the item's requirements? We emphasize model acceptance criteria. The model is only usable once it can be demonstrated to satisfy rigorous safety requirements. FAA's approach is to translate the learned model into something verifiable, often expressed as a mathematical representation. This allows us to apply proven verification techniques, treating AI as just another component we can test against requirements. Once the item is verified, it moves to the system integration and then to the aircraft level, where it has to interact safely with all the systems on board. This staged approach ensures AI is held to the same discipline safety framework as any other onboard system. AI is not treated as a black box. Instead, it's managed through structured development, verification, and integration, always with safety as the anchor. This incremental, rigorous process ensures that AI enhances aviation safety rather than adding uncertainty or risk. So also, I want to emphasize our approach is to use as much of the existing regulatory framework and standards as possible. That includes DO 178C, DO 331, DO 254 for hardware, ARP 4754 and 4761 for systems and safety. I think there's a lot of alignment there with EASA as well. Last slide here. So last month, July 23rd, the White House, as my friend Christine Berg stated this morning, unleashed the US AI Action Plan, which fully aligns with the engineering approach I've outlined here today. This plan reinforces FAA's roadmap and underscores the AI in aviation will be managed through rigorous, disciplined processes, no hype. First, it reaffirms that AI is treated as a software. It is not a pilot, it's not a crew member, and it's not an intelligent being. It's a system component. It's a system component that must be verified like any other. Second, the focus is on performance, reliability, and predictability, making sure we only trust the output, but also understand how the system behaves. And third, it stresses the importance of advancing the science of measuring and evaluating AI systems, giving us tools to consistently verify safety. This action plan strengthens the FAA's approach. Our AI roadmap is a living document, as I stated earlier. It will evolve as technology evolves, but our North Star, aviation safety, does not change. Finally, as my colleagues Maria Reda from EASA highlighted earlier this morning in her opening remarks, none of this happens in isolation. FAA remains committed to harmonization with EASA and our international partners, which many of them are sitting in this room today, so that AI strengthens aviation safety globally, not in fragmented ways. That's how we ensure public trust in AI and aviation through consistency, cooperation, and uncompromising focus on safety. Thank you again for this opportunity to share the FAA approach on AI. And if you have any questions, since I'm only here on behalf of Dr. Pham, I would encourage you to contact him, but I will try to answer some of your questions with the disclaimer, I'm not the AI expert. So my question is to you. Thank you. Thanks, of course, absolutely.
Statement that no machine learning at this point. Does that apply to all DAO levels or just DAO C and above?
As far as I understand it from the download I received from Dr. Trung Pham last week when I got this presentation, that's the current position, because we don't see that we're there yet. That doesn't mean that we're not open to talking to you as the applicant on those technologies if you have R&D going through that, if you're doing R&D and you're developing towards a production level product, we will certainly talk to you and we will work with you, but we are not there yet. Thank you. Of course. Yes. Yes, sorry. So you may. Yeah. Make sure everybody online hears it. Right here.
Thank you very much. Of course, the FAA is implementing the policies that are set by Congress and by the president. And since the action plan was published, J.D. Vance has also spoken to the path that he sees the United States taking with regards to AI regulation. And a big topic, of course, is deregulation rather than regulation.
Yeah.
Do you see that potentially at odds with the FAA's mission and more specifically, as you've said, safety remaining first and foremost?
So that's a great question. Thank you. That's a current conundrum that everyone is dealing with in the FAA rulemaking office. So we are certainly, and then for some of you, the mandate in some cases is looking to review 10 rules whenever you want to add one rule. So in a highly regulated aviation industry, that's quite challenging. We are evaluating that. I don't know if that's going to lead to a lot of rules to go away. The reality is a lot of the rules that we have today, and us, EASA, and everybody else, they're written in blood. And that makes it very difficult for us to eradicate those rules. And those statements at a higher level, they go across many sectors. So from an aviation perspective, where, again, our safety is our #1 priority. Hopefully that answers your question.
Okay, if we can just take the one last question from the gentleman in the blue shirt here, because then we need to move on just for timekeeping.
Hi, thanks for the presentation. You were focusing on the software on board the aircraft, essentially. But I mean, since FAA's remit is safety in general, where do you see the difference with like what we have with EASA that also covers other uses of AI which can impact safety? I mean, I think the clear thing is always going to be safety, but let's say an AI for maintenance and making or assisting decisions on that has a safety impact. Is that on FAA's roadmap yet or not?
All right, so there's a couple of questions in there, but I'll try to answer it quickly because I know time is limited. So this is a question I get asked a lot because I'm responsible for the relationship between the FAA and EASA. And everyone comes to me and says, what's the difference? Why are you guys, why don't you march in the same pattern? And the reality is our rulemaking processes are very different. The cycle of rulemaking, correct me if I'm wrong, in Europe is probably anywhere from 18 months to 3 years. Where in the US, it could be anywhere from 5 to 10 years. It's just we don't have the means to change rules or modify them in any way. So when we develop the data and the knowledge from industry to get to that stage, it takes a long time. So that appears to industry and appears to everybody as if we're not working together. But in reality, we're always in communication. We're always talking. We're always sharing information. And what happens is sometimes, and it may happen here too as well, where rulemaking in EASA will probably happen before the FAA. And we're fine with that because we will need good data and knowledge and understanding of the technology. So that's why we do a bottom-up approach to answer your question a little bit better. We're looking at it from software, a very focused area. And as we learn from that experience, we will expand that out. And that's just the reality. AI is going to be infiltrating everything within aviation. Thank you very much. Appreciate it.
Thank you very much. So we're now going to move on to our second flash talk, and for that we will welcome Fateh Kakai from Thales, who is the safety expert and AI assurance researcher for them. He's going to update us on the Eurokai and SAE working group. So Fateh, I hand over to you.
Hello, everybody. Good afternoon. I will not be alone today. I will have my colleague Sandrine Serres from Airbus that will do the presentation with me. Close to the mic. Is it better like that?
Yes.
Okay, perfect. So, do we have the slides? Yeah, we can. It's like this. Okay, perfect. So, Sandrine, I'll let you start.
Okay, so thank you very much first, EASA, for letting the floor to us to present the work of the working group 114. So we'll start by presenting the working group. It's all a reminder, and after Fateh will focus on the draft 7 and the open consultation which is currently occurring. So just as a reminder, the committee is in fact a joint committee. So we are working all together between SAE, it's the G34 committee, and the Eurokai working group 114. So as you can see, Paula is remotely connected. You have also Matt in the room from Boeing. Paula is from Embraer. You have in the room Gary from Airbus. And at the Eurokai level, you have Fateh and myself, and Radek as the secretary. And in the committees, there are a lot of industries, authorities, and also universities. We have published 2 important documents. The first one is the statement of concern. So it's the ER22 and the IAR for the SAE part 6988. This document provides all the gaps regarding the existing guidelines and identify all the gaps that has to be filled. It was published on April 2021, and you can find it on the Eurokai website or SAE website. You also have another important document, which is the Taxonomy 1, published in December 2024, which try to provide taxonomy information about what is AI and what are the several techniques of AI. And of course, we have 2 publications in progress. So, sorry, 2 standards in progress. We have a development and assurance process. It's a guideline for development and assurance for aeronautical equipment and product embedded AI. This publication is planned in June 2026, and it will integrate some use case to illustrate how to implement the process that we provide. And you will have another document which will be dedicated to the use case to implement the W-shape or the MLC development process. That's all for this. So regarding the gaps, in fact, we all know that you have the IRP 4754 and IRP 4761 for the safety assessment at aircraft level and function level and system level. And you have on the other side the item guidance, like the software ones, the DO 178, and the hardware one, like the DO 254, sorry. But on these, what has been identified in the statement of concern is that you have additional considerations to be tackled due to AI, because first, it's not knowledge-based engineering. It's really, you have disconnection between the specification as it is a model-based, a data-based, development. The next point is the fact that the design is complex, can be complex for ML model, and it is not directly understandable by the humans. And the last consideration is the fact that the design, the low-level design developed by the machine is not directly traceable to the functional needs. And all of these have leads to the fact that we develop a MLC development process to ensure that the development of an AI-based system remains safe when embedded on aircraft. So the scope, this is just the global information, but the scope for the ED 324 or the IRP 6983, the ED is for the EuroCAE document and the IRP is for the SAA document, recommended practice. The scope of the issue 1 is limited so we provide in the guidelines a development assurance process which focus on the learning assurance. The scope covers both airborne and ATM-INS domain for crewed and uncrewed aircraft. But the issue 1 is really limited to a subset of machine learning technologies. So first it's non-adaptive ML, supervised mode, and for the IDAL allocated to the MLC, it's up to IDAL C, assurance level 3, or SWAL for ATM-INS domain 2. What is also not covered, but which will have to be covered, are the considerations related to the information security and to the human factors. And now just let's focus on what is interesting for today. It's the fact, so this is the master schedule. There is a lot of detail. There are a lot of details and you don't care. What is really interesting is that we have frozen the draft 7, which entered in the open consultation by the end of July. And the open consultation will be then closed by mid of September. And this will be the first time, that our standard is proposed for consultation to all the industry which wants to review it, to comment it. Because before it was internal to the committee. And so, as you can see, after a loop of comments resolution, we plan to publish it for the beginning of June 2026, which should be aligned with the EASA NPA proposed for public consultation.
Thank you, Sandrine. So I will give you some highlights regarding this draft 7 and what you will have to read during the open consultation. The target date is the 15th of September, just a reminder for you. So the first highlight is related to the interface between the system engineering layer and the ML engineering layer. So you have clarified, I would say, this interface in the draft 7, and it provides, I would say, clarification on what is really the scope of what we address in our standard. So actually, the standard is addressing the case where the machine learning is used to develop on the left-hand side of the slides complex models that I would say develop a system function, like for instance object detection and classification of, I would say, object on a runway or something like that. So it is something that you can see in the system requirement. So it's really a high-level need in terms of high-level functional need. And actually here, the machine learning will allow to develop a complex algorithmic, I would say, model that needs to be, I would say, verified to be sure that this complex model, this complex algorithm fits the intended purpose and can be considered as a source of truth for the implementation. And we cannot go directly to the implementation or to the software consideration without being sure that this complex object satisfies the needs. So this is the left-hand side part. And the right-hand side part is when the machine learning is used to develop simple, I would say, models that are embedded into one item. It can be a small classification task or something like that. And our standard allows to cover also this case. And what you have seen when we did this, I would say, the analysis of scalability is that the objectives and the means of compliance that we have in our standards scale very well for both, I would say, cases. So in the draft 7 and in the appendix, you will have more supportive information that explains the difference between the two cases. And that, I would say, clarifies the things. Second highlight is that we improved a lot the documents in terms of readability, in terms of structuration, and we have, I would say, analyzed all the interfaces between the different blocks that you can see here, which are related either to system or integration, I would say, system or integral processes consideration, the machine learning algorithm, algo engineering, I would say, level, and also the software or hardware implementation level. And I would like to thank all the members in the committee that have, I would say, done this deep work of ensuring the consistency between all the interfaces between these blocks. And here I can see my colleague Florence de Vancé and also Geoffrey Delhomme, etc., that have done a very good job on that, and others also. And you have on the right-hand side of this slide a comparison between the size of the different standards that have been mentioned today several times. And we can see that if we focus on the normative part and the main body of the document, well, we have in our IRP 1693 ED 302, I would say, a main body that is a bit longer than the others. It is also justified because with machine learning, we add an engineering level, which is a machine learning engineering level. So we have this W shape with two V cycles that are integrated. And we are manipulating more engineering artifacts. We are manipulating data because we should ensure that the data is representative, complete in order to ensure a good learning process, etc. So we have more artifacts to manage than in the traditional V cycle with software implementation or hardware implementation. But somehow we can see that we are quite, let's say, equivalent in terms of size of the standard. But during the open consultation, what we can see is that maybe we can add more supportive information because we can see in the other standard that there are more, I would say, information there. So it's something that we can do by adding, for instance, end-to-end use cases to illustrate the activities proposed in the standard. So here, for instance, you have a list of use cases that are handled today within the committee. I will not go through all the list because I see that maybe we will not have time, and I see Guillaume that is looking to me several times. So you see that we have material to integrate into the standard. And just to finish, we have two subgroups that have been created, I would say, a few months ago. One related to human factor considerations in order to start, I would say, addressing the AI levels as described in the concept paper, and which is related to this human factor aspect.
This one is newly created for EuroCAE officially, but this subgroup is working since years, huh?
Exactly.
Just to be clear.
And the second one is on information security, and it is the same to analyze the impact, the concerns on information security. This is, I would say, also a subgroup that has started to work, but that will be created officially very soon.
And both groups are working together with other committee at SA level or EuroCAE or other.
Exactly. So to sum up, I would say we had a very good internal review of the document that raised a lot of comments. I'd like to thank everybody for reviewing it and providing these comments. These comments are being addressed. We have addressed a lot. Some are remaining. We have launched this open consultation on EuroCAE site. We will also collect a lot of comments, and thank you again for, I would say, reviewing this document and providing your valuable comments. We will have a second ballot on SAE side in order to validate the changes done during the open consultation period. We target to publish in 2026, hopefully in June, of next year. I have said something regarding the use cases that will be integrated to enrich the supportive information in the standard. And in the I would say next work, we envisage to also address more techniques in order to provide guidelines that will be useful for the community. Thank you very much.
Is there any question?
Any comments or questions?
Okay, thank you.
Thank you.
Thank you. So thank you very much for that. So next up, we're now looking at how quickly we make rules, I guess, to follow on the comment earlier from Mastak from the FAA. So for this, I would like to welcome Giovanni Cima, who is from EASA. Thank you.
Thank you and good afternoon, everyone. So my task today is to talk you through our rulemaking activity over the last year and explain you what we did, where we are at the moment, and what's next. I can tell you that it's a long journey that started 1 year ago. And for those of you that were at the AI days 1 year ago, I would like to pick up exactly from there, where we show the rulemaking concept that we started with as taken from the AI roadmap to zero. So this is exactly the slide of last year, where you see that the starting point is the AI Act, which requires us to, by amending the basic regulation in certain articles, requires us to take into account a number of provisions, particularly those of Chapter 3, Section 2, when regulated aviation. So starting from this basis, we initially developed a concept of an AI aviation regulation that was initially referred to as provisionally as Part AI, where the intention was to have in the step 1 of the rulemaking process that was translated in the first MPA, that is still under work, to develop a generic framework for the deployment of AI in aviation, supported by the necessary AMCs and GMs that we're also calling the standards, and then to connect this generic framework in the step 2 to the other specific aviation domain regulations and the related AMCs and GMs. However, in the first months of the work, we received feedback from various sources, starting with the Commission in particular, where a discussion was started on the legal basis of the work that we were doing. And this is particularly important because it relates to the empowerment that we have to touch certain rules and to the mandate that EASA has, plus some other clarifications on the interplay between the AI Act and the basic regulation. In parallel to that, we also got feedback from industry, and this was done through the advisory bodies. The main advisory bodies of industry at EASA is the SAB, as many of you may be aware, and the SAB overarches several working groups, one of which, the 005, is related to aircraft design. In the meetings of this group, concerns were expressed by industry on the scope of the Rulemaking Task 742 and the concern of over-regulation by having a Part AI. So we started a reflection and took into account this feedback into a replanning strategy. And based on that, we decided a reorientation of the Rulemaking Task 742, in particularly on focusing the first MPA on soft law only, and I will explain you in a moment what we intend by that. This only for the aviation domains, strictly in the scope of Article 108 of the AI Act. And these were three basically, are airworthiness, ATM, ANS, and drones. So with this in mind, we changed a bit the rulemaking concept. So we moved away from the idea of having a part AI, and we refocus the first MPA only on soft law by developing a detailed specification. A detailed specification, or a DS in the EASA language, is on the same level of a CS, but is used in other areas, so to speak, because it's not about the certification of products. It is not very well known by many because we don't have many DSs in the EASA regulatory ecosystem. We have only DSs in the domain of ATN, ANS, conformity assessment for equipment. But we thought that this could be a good way to approach AI. So basically, we kept the concept of having two steps in our rulemaking. So the step one was still building a generic framework for AI trustworthiness through a DS and a set of AMCs and GMs, like it was already mentioned this morning by my colleagues, and we'll come back to that and the link with the AMCs and the GMs. And the AMCs and GMs calling, when necessary, also the standards. You see here there is a circular loop between the work being done at EuroCAI and SAI, but also with other standards like ISO and SENS and ELEC, because these are also linked to certain parts of the AI Act. So we need to take into account what happens also in other domains in case we find it relevant for aviation as well. Now, after that, in the step two, we will have to connect the generic framework to the aviation domains, either through CSs or DSs or to AMCs and GMs. And we will see that it was a bit anticipated this morning by Francois, but we will come back to that later on in the next few slides. Now, I want to spend a few words on more on the content of the work, coming back to the terms of reference of our rulemaking task that was published last year. We were still working on the composition of the rulemaking group when we had the AI days 1 year ago. But here to remind that the terms of reference as it was issued last year, contained 4 subtasks to be conducted through 2 steps that were the 2 MPAs we were talking about, and it also included the rulemaking group composition. Now, all our rulemaking tasks are contained in the EPAS. For those of you less familiar with the EASA documents, the EPAS is the general planning document that we have at EASA and that is amended every year. So this year we will issue a revision to the terms of reference, where we will reflect the changes that are already happening in the rulemaking group, in particular the repurpose of the step 1 to soft law, the timeline. We will revise the timeline a bit. We will also clarify that this rulemaking task will require a full impact assessment, because the current terms of reference says light impact assessment, but that is only for the step 1. The rulemaking task overall requires a full impact assessment. And then we will also explain better the next steps. When it comes to the rulemaking group, you can see here the composition of the group as it is today, and which is published on the EASA website attached to the terms of reference. It is a very large group. It's quite a unique case. The way we made it, we started with an initial list of recognized experts that were submitted to the advisory body for consultation. And after that, we got more proposals for additional experts that we were happy to take on board on most of the cases, because we wanted to have the best possible coverage and representation of aviation domains, technical expertise, and also stakeholders representations. Here in the table, you can see how many boxes we tick, and it was a bit of a difficult exercise because we had to reconcile two contradicting needs. On one end, to have the best possible representation. On the other end, the need to keep the numbers reasonable, because the larger the group, the more difficult it is to manage it. Nevertheless, at this point, we have still identified one or two possible areas where you can augment the group, and this will be also reflected in the next edition of the terms of reference. Now, I also want to summarize what we did in 1 year, because we kicked off the work of this group in September last year, and in the following months we have 12 meetings, mostly online, and we finally managed to have a plenary in-person meeting in May for 2 days, which was a meeting where we made major progress. We really achieved a lot in processing and resolving the comments on the group. And we will take the opportunity of the AI days now, because many members of the group are sitting on the room, and this is very good. So we will take this opportunity to have another in-person meeting at the end of this week on Friday. And the point where we are now is that the MPA 1, the step 1 of the rulemaking task, is nearly completed, and we want to finalize it and prepare it for publication, and then also anticipate what will be the things to do in the step 2. Here I want to recall a slide that was shown this morning on the scope and the structure of what we are doing in the rulemaking task. You can see on in the yellow box the step 1, which will be the content of the MPA 1. This is the detailed specification for AI trustworthiness with the associated AMCs and GMs. This, like I said before, constitutes the generic framework for AI, but it needs to be linked, to be connected to the aviation domains, the 3 aviation domains given by Article 108 of the AI Act. In doing so, we need to establish a link as necessary, and it is particularly important to say as necessary, because as it was explained this morning, we don't want to reinvent the wheel, and when there is a domain that has already a framework that is comprehensive of work, we want to use it as much as possible, and just to complement it with a few bits that are specific to AI and that cannot be covered today in the existing framework. So, for example, I give you in the initial airworthiness, where for the safety assessment we have the framework of 1309. This will stay, but only in the AMCs and GMs we will call some specific parts of the AMCs and GMs of the DS. Similarly, will happen for ATM and ANS and for drones, which is the third domain. Having said that, I present you here the structure of the DS as it stands today. We have, apart from some initial provisions where we give the scope and the definitions of the terminology used and the acronyms used, for those who are worried about having too many acronyms in the rules. And then you see the various points that are coming out from the building blocks. So we will start having provisions for the concept of operations, for the classification and the levels of AI-based systems, for the OD, for the system risk assessment, the ethics-based assessment, the system intended behavior, the continuous risk assessment, and human factors. So all the blocks that were covered by my colleagues this morning in more detailed. And what I can say here is that typically the technical standards of the DS will be very much high level. We'll give general concepts, and all the content will be at AMC and at GM level, And where necessary, the AMCs and the GMs will call the standards, particularly the 324. And I want to conclude this briefing with the timeline as it stands today. And you can see that there are two different timelines here. The one below in orange, which should not be taken as an amber caution, is the timeline of the AI Act, where we have by August 2026, the entry into force of the requirements for high-risk systems, particularly Chapter 3, Section 2, and the Article 108, while by 1 year later, by August 27, we have the entry into force of the classification of the safe components, which is the Article 6.1. Based on that, we made a planning of our rulemaking task, which is what you can see in the upper part. And we initially thought to have the MPA step 1 ready by Q3 this year, and the MPA for the step 2 at the beginning of next year. Now it's likely that there will be a delay in this timeline, though at the moment we are on track. We have everything we need to proceed, but we will see, because there could be still some discussions to resolve, and it could be that it takes more time. But it's not very important, because what will happen in the next steps is that the two MPAs will, at some point after having the public consultation, will be merged, and instead of having two opinions, we will have only one opinion that will gather all together all the tasks and subtasks of the Rulemaking Task 742, with the idea of publishing the regulatory part that will be very slim by 2027, and the associated ED decisions for the soft law containing the DS, the AMCs, and the GMs. One thing that I want to mention for those of you less familiar with the rulemaking process, an MPA is not a rule. MPA stands for Notice of Proposed Amendment. It's the way EASA has to make an initial proposal for new rules or amended rules, and this is subject to public consultation, where we gather comment from a larger audience than the rulemaking group, and then we process these comments, and then finally we inject the result into the opinion that will follow. So that's all I had for this presentation, and we are of course available for Q&A.
Yeah, I will just put a Slido, and you can.
Maybe it's better if you manage the Slido.
I will manage it from there. No worries. I'm just putting it on the screen. We don't have many. We have two questions for now, but let's see more live comment.
Okay, so first question, why EASA is focusing more on ethics of AI as compared to safety analysis of AI for aviation? I don't know if we are focusing more on that, but I give the floor to Ines for this.
Thank you. Wow, what a guest. Well, safety first. Safety is our mission. We are EASA, right? So, of course, we want to have safety plus an ethical, responsible AI-based system. So we want, of course, this is what we want to accomplish, to have a safe but also ethical AI. That's what we want. So it's not the question of being more or emphasizing more ethics over safety. It's not that question. Thank you.
Okay, so next one, for AI systems in civil aviation products that don't require an EASA approval, which regulatory framework will need to be complied with, EASA DS or AI Act? Well, it depends. It's probably linked to what Guillaume explained this morning. So I don't know, Guillaume, if you want to elaborate on that.
Yes, sure. No, you're right. Giovanni, it's connected to what I was mentioning this morning. So we first need to exactly delineate where we require or not an EASA approval. That's surely the key element in the question, and that's what we are working on. In particular, again, with the two cases I was showing this morning in my presentation, and the clarification on what we do with the notion of operational tools. That's quite important to say we are not completely at the end of the definition there. Now, when it doesn't, definitely, the AI Act is an horizontal law at a European level. So it's not, let's say, the EASA frame of encompassing high-risk requirements for, requirements for high-risk systems like Christine Berg was mentioning this morning, doesn't bring away from the fact that the AI Act contains a number of articles on obligations and so on. So this applies, I would say, anyway to a company. You still have the obligation, for instance, to not undergo a development of a prohibited type of system. So this will not be done by the EASA framework. This is law at European level. If you go for a prohibited system, this is not about EASA to say you shouldn't do that. It's the European law. So the AI Act will apply, I would say, whatever the case. But for what pertains to requirements on safety, meaning on what they call high-risk system in the classification on the AI Act, this is where we have, through the Article 108, this, I would say, cascading into the basic regulation to take into account those requirements. And this is what we are doing. So I think this is where, when a system is not required to undergo a certain, let's call it certification, qualification, whatever, or approval, through the trustworthiness framework, we have two cases. Either it is directly managed under the aviation framework, and because it's non-safety, I would say it's not submitted to any additional requirement, or it has to go, let's call it, back to the notion of trustworthy conformity assessment from the AI Act, but because it was determined as non-high risk, therefore low risk, it is also not subject to additional requirements. So I think in both cases, we end up in no additional requirements will be leveraged on anything that doesn't require an EASA approval. Anticipated consideration, again, to be completely consolidated with the rulemaking, the legal basis assessment, and so on. I'm just preliminarily explaining what we anticipate.
Thank you, Guillaume. So the next one, when domain-specific AMC and GM are finalized, will they replace generic AI AMC GM, or will specific AMC GM apply on top of generic AI AMC GM? No, well, the idea is not to replace, the idea is to complement, meaning that we want to use as much as possible the existing framework when it works, like it is the case in ATM or in certification or possibly in other domains, and just put a call for additional means of compliance when they are needed because they are specifically specific to AI. So basically what you will see that in the AMCs or GMs of the various domains, where necessary, and I repeat, where necessary only, there will be calls for specific parts of the detailed specification on AI.
I will just put an additional note. Thanks, Giovanni, for the answer. Why are we trying to do something factorized in AI specific AMC GM is precisely to maintain the framework and to say that whatever pertains to machine learning should be maintained in a centralized way, whether we are talking about product certification or an ATM conformity assessment of an equipment. That's the ambition. But after, definitely AI AMC don't replace domain-specific AMCs. They will be called, as Giovanni was saying, from there in a totally, I would say, different way on both sides because the framework are different. But if we can manage the generic AI trustworthiness framework as a centralized element, every update we will do because of expansion in technology, because of novel elements we know, because of ramping up in criticality, etc., can be actually factorized for every domain without having to re-rule make, I would say, each time we have a change. So this is the idea. And again, let's see what the domain specificity brings us. That's quite important to keep in mind.
Thank you. So next one, in FAA's presentation, learned AI is mentioned as static and deterministic. Keeping in mind the nature of AI, isn't it a big assumption? Okay, so it's a question, I think, both for, yeah. Yeah.
Testing. Okay. I'll try to answer the question again. I'm going to defer to Dr. Pham for further details on this, but I'll use the analogy that we're looking at Learn AI in the same way that we look at software. If there's iterations, at a certain point it gets locked, and that configuration gets reviewed, approved per the criteria that's set for it. So the same analogy applies for Learn AI. If it's Learn AI, it's come to a certain level of maturity, it gets locked, and it's from our point of view, it's static. It's not going to keep learning, and that's what we mean by static and deterministic. But that doesn't mean that you can't continue collecting data as the system is on board and use that data for the future iteration of the next level of the AI system.
Thank you. So next question. Are EASA FAA involved with the working group 114, group G34? If not, are these guidelines actually becoming an acceptable means of compliance? Yes, we are involved in the working group, but I think the two questions are a bit not really connected because we refer to the standard, though it's not published yet, but the intention is to use part of it. And but this is not linked to the fact that EASA is part of the working group. I mean, it is in a way, but not directly.
No, indeed. We, as usual, we try to make the most use possible of industry consensus standards in order not to reinvent the wheel. We are in a case where the standard is not published. Therefore, we still have to keep somehow part of the IMC is for the case where the standard will not apply. Two reasons, of course. One would be we are, at the end of the day, not satisfied with the standard itself, which is not the direction we see coming, because we are engaged, especially, I would say, to help the group seeing what exactly we are expecting. And so far, we had a lot of work in the past 4 years, or even more probably, to align our views, to understand what is needed, to refine everything that you heard about the W-shaped process, etc. So I think we have no doubt right now that we will be, and that the group will be successful with the standard. But still, the standard has a certain scope, which is initial airworthiness or product certification and ATM. ANS. So if we anticipate some guidance to be applicable to other domains, like why not production, maintenance, and so on, definitely we need to keep a foot in the door with the IMC being a bit more comprehensive in terms of requirement than just a call to the standard. That's why we have taken this kind of dual approach, which allows to react to any case. But definitely we are disconnecting the two. If the standard is good, that's let's say in the interest of everyone, including industry for sure, that we call it and that we recognize it. Else we have for certain domains to anticipate that maybe that might not be the right call of guidance, and probably there is at least a kind of an abstraction layer of requirements to keep on the plate to say that maybe something else is needed for other cases, other domains.
Mm-hmm. Thank you. So next one, will rulemaking also address the use of AI by the authority in certification or audit processes, e.g. the use of AI to analyze manuals, documents, reports? We have foreseen in the step 2 of the rulemaking task the impact of AI on organizations and on authorities. However, at the same time, we have to keep in mind the limits that Article 108 is giving us today, that is restricting our action to 3 domains. So for, let's say, for activities of certification and oversight at large that an aviation authority may do, we will have to go step by step as we have the mandate to act on a domain or another. So I would say probably yes, but in time, not immediately.
Can you repeat that?
Regarding the standards, that I think we're aligned with what William mentioned earlier. I think we will continue to work with the standards and entities, institutions. The work will continue for sure. As far as if it will be a strict means of compliance, I don't see a question up there anymore, but if I'm recalling the question correctly, I don't know if that will, that's going to be determined down the line.
Okay, so next question. How will EASA proceed for aspects not covered by ED 324 when published in 2026 and no update for EIF? For example, human factors, ethics, information security. We have at the moment a proposal to tackle human factor, ethics, and information security in our MPA. So that would be the first approach. However, any development that there could be in the future in the standard will be, of course, followed and taken into account. Okay, next for the FAA. So considering the reuse of legacy regulation documents as is for DAL-D items, can the applicant make use of AI as a design choice without claiming it?
Did I mention that I was not the expert, but I'll try to answer. So let me reread it again. So from our perspective, we're trying to integrate AI into existing frameworks from an item level, as I explained earlier. And we want to make sure that if there is existing regulation, we're not going to reinvent the wheel. And that's it. But as an applicant, we hope that you will definitely disclose to us that it is AI as a design choice. And that is part of the whole certification and discovery process with us in our offices. So, ethically, I hope that you would be fully transparent with all that. Thanks.
Okay, so next question. Decisions on the GM-AMC are expected in Q4 27 after the entry into service of the AI Act in August 27. How do we manage the difference in the timeline? Okay, there are several things to explain here. First of all, it will not be the first time that there is a slight misalignment between let's say, regulatory deadlines. However, when it comes to decisions, a decision may have 2 types of content. One that is related to an opinion, meaning that there are the AMCs and GMs attached to implementing rules. So these 2 have to go together, and the decision can be published only when the implementing rules are out. Or it could be an ED decision containing only DSs or GMs, AMCs that are totally in the hands of EASA. In that case, we have more freedom to play with the publication and the time and the applicability date. And particularly for the DS being completely new and managed by EASA, if we are ready before, we can anticipate the publication of the DS, and then the rest attached to the implementing rules of the various regulations will follow. Also having in mind that when an EASA opinion is published, it's not yet a regulation. It has to go through the legislative process in Brussels with the Commission and the Parliament to be turned into an applicable European law. Okay, next one. Is EASA in consultation or considering military ML functions for peacetime use in civil operational environments? Not at the moment, but it may come our way. I don't know, Guillaume, if you want to expand on this.
Yeah, we have connections because we have an advisor to our executive director dealing with military topics, and from that side and from the European Defence Fund research projects, etc., we see more and more AI machine learning and more than machine learning coming. So there are some synergies indeed that we surely will use, and you know that synergies exist anyway in the dual use type of aircraft. So I'm pretty sure the connection will be done. We don't have a current active project, but I'm pretty sure that will come.
Thank you. And the next question, is there a plan on how the ethics assessment of AI applications is going to be integrated into this new form of soft law that was mentioned, checklist guide?
Yeah, as I was just mentioning before, yes, we are in the making. So we are discussing in the rulemaking group and with the stakeholders how these checklists can be put together. So the goal is really to do an ethics-based assessment on a practical and easy mode, yeah, and have this first step where you can really analyze and decide if you want to go further on your analysis or not, yeah. So, and it will be integrated, of course, aligning with the AI assurance and the human factors part.
Thank you. Next question for the FAA. How the published America's AI Action Plan applies to FAA roadmap regarding repealing the legal barriers and the no registry audit aspect?
Yeah, thank you for the question. So this action plan was just published last month, and in the implications of it to the FAA roadmap, as far as we understand it currently, it does not change our framework. As far as those repealing legal barriers, that is all being discussed internally in our headquarters, and we'll probably have further details about that down the line. I can't really answer that right now.
Thank you. So next question, will quantum computing working with AI be considered as part of the rulemaking task or as a concept paper?
We'll take the question, but no, that's an interesting one. We are talking about it more and more. I would say no, it's not part of the RMT scope currently, clearly not. One thing that is different but still connected, we have anyway the challenge of hardware in general for AI, meaning even I would say specific processing units developed for AI to provide acceleration capabilities. This type of hardware is already a challenge for the implementation of systems in the current, under the current certification framework, irrespective of the AI use. And quantum computing could bring actually probably not onboard capabilities straightforward, but maybe accelerating learning capabilities or data management capabilities, which probably will be a bit transparent in the first time because the W shape doesn't really insist too much on the hardware for training, on the environment for training. Of course, there's still the question of, are you taking certain credits on that environment to reduce certain activities of verification in the traditional V-shape verification, etc. This I don't want to enter in, but if quantum computing really proves to bring, let's say, added value, it will be probably in a pretty transparent part for the start. But after, we have no crystal ball. So at some point it might be, but today it's not in the under the AI roadmap, and it's not in the RMT scope to be very clear on the question.
I think if we can just have one last question now, and then we need to move on. So not just because the questions are getting harder.
Okay, so focusing on soft law, does it mean part AI will come later or it is no more necessary? NDS plus AMC and GM are sufficient to define AI regulation framework? Well, that's what I said before. We have changed the rulemaking concept from dedicated AI rule part AI to a soft law approach, which is composed by the DS plus the AMCs and GMs. So we consider at the moment that the package DS, AMC, GMs is sufficient to define the generic framework for AI in aviation, and then it will be connected in step 2 to the rules of the various aviation domains.
Can you take the next one, Jeremy, because you didn't mention...
Yes, yeah. Well, it was what about part AI OR and AI AR? It was somehow briefly touched in a few questions before. Indeed, we need to assess in the step 2 the impact of the use of AI on organizations and on authorities. So this will be done in the various domain regulations.
Exactly, that's the important point. It will be done domain by domain and not anymore in a centralized part AI. So part AI is really off the table, just to be very, very clear on the answer. Thanks.
So I have people from 4 groups. Maybe you can, Zagi and Sophie, and I'm missing somebody. Yes? We have everybody from all of the groups. Am I missing somebody? No? No, okay. So as you can see, we were supposed to have like 3 or 4 priorities for the benefits and then 3 or 4 for the challenges, but we could manage. Why is this so? Because it was so interesting and so rich, the discussion, that we decided to put the priorities of everybody there. So what I'm going to do is I pass over the floor to each of the groups for them to explain a bit what were the important ideas that they found out, okay? So, who wants to start? Carmen, maybe?
Okay. Okay, in our very fruitful and inspiring group, we was a very mixed group, and there was one benefit. We find out a very overall benefit that that by dealing or handling or including ethics in the design process, we increase trust in the system and in our domain, the aviation domain. And that is not only for the users, end users, operators, also for the passengers and for the overall society. It was one very overall benefit. But there's also a challenge because from the perspective of the engineers and also the people who have to implement and develop AI-based systems, it could be a burden. Just now, especially, we find out in our group, there is no clear understanding what is ethics, how to deal with it, and it should not only be to work to set checks in the checklist, it must be coming from the deep understanding, and so there is a gap, we think. And we have a third point, so then we also think it's very important is we talk about biases, not only about AI biases, we already know, but also about human biases in the data. And we have an example in our group. It could be that there are a bias in the data, for example, a preference of air traffic controller for a specific procedure. The system learns this bias, but we want to, for ethical reasons, we want to have unbiased data. And so we clean the data, and the final algorithms is very ethical, but not accepted by the controllers because their preferences are in. So what we discussed is finding an appropriate way to handling human biases and AI-based biases. So that was my third point.
Thank you. Lovely. So next one. Sophie will be the last one.
Oh, last one.
Yes.
Oh. I mean, we all talked a lot about different things. So one of the things that we also had in the discussions this morning was like de-skilling. And there's 2 aspects then from an ethical perspective is is essentially, do we have intentional and unintentional de-skilling? So this morning, we talked a little bit about the kind of unintentional de-skilling, which is more a human factors aspect. How do we make sure people don't get complacent, don't lose their skills because they over-rely on being able to push a button and see the magic happen? And so having this kind of ethics checklist can help us identify that or flag it up as a risk so that we can then treat it down the human factors path. But there's also the aspect of the intentional de-skilling, is because to some degree we'd be doing AI to take over roles of humans. How do we find that acceptable? It's a societal impact as well. And this is where we need to actually have a good way of saying, how do we assess and how do we make it acceptable to society? Because these are things that we've already done. Is we can't just say, well, we have to keep all the roles that everyone has now frozen forever. We haven't done that either. Is we used to have the flight engineer, and we have been able to transition from that in the past to having 2 pilots in the cockpit. So there are ways that we can accept it. Is yes, some roles have disappeared. Some people have lost their jobs, but a lot of other jobs have been created. And I think in kind of the intent of the AI Act is how do we make sure we do this in an appropriate way, in a safe way? And in aviation, there's so many other factors. It's not just this one aspect, because if we want to talk single pilot operation, to say, well, could we go that further? We know there's a lot of other discussions that would have to go through. It's more than just this one ethics, but it is something that helps us as a checklist to say, are we going in the right direction? Then another thing that we talked about with like biases is having this as a checklist might also help us create the models better, because as we had from the survey this morning, the survey 80% men, 20% women, we see that it's a specific age group, which means if you're building your models off of such skewed data, it might not actually work in all of the spaces that you want. Because if you think of something like facial recognition, if I do facial recognition based off of a data set 80% men, it's probably not going to work that well on women. If I don't have different skin tones, things like that, this is things that we've seen in other aspects of AI, it just doesn't work right. And so while I don't believe that in aviation we'd really be having applications where we intentionally have discriminatory bias, just having these kind of questions would actually help us to identify, are we going to set up our data sets that we use for training to make sure that we get a better thing? Because for me, that would be an operational failure if we do that, but it came from a bad or a misinformed starting point.
Thank you. Lovely. Next one.
My turn.
No, I'm going last.
Hi, good afternoon. I believe everyone is praying for the rain to stop before the session. So, this is Hamid. I'll be speaking about the benefits of the AI. At the beginning, we cannot say that there is no benefits. There's huge benefits. I'm listing here 4 of the major benefits. Time consuming. It will reduce time. It will reduce efforts, along with money and resources, and quality. It will produce a very high quality in job. But there is challenge. So along of group 4, we discussed several challenges, but I can see smiles around there. But one of the biggest challenge that the generation gap. There's a generation gap between in the aviation industry, a well-experienced generation and a young generation who are hands-on with the AI since the beginning of his life. So how we do combine the experienced generation along with the AI usage to get the ultimate usage of both, I'm gonna say. So this is a challenge, but lucky us today, we have a solution for it. It's maintaining life without AI. So let us prepare for a day that we kill the AI. We need to maintain a certain experience and knowledge, even with using the AI. We don't want to lose our skills. We don't want to lose our experience, especially since the past accumulative experience since the past 100 years. So this is our discussion, and this is what we led to. And I hope we get satisfied on this matter. Thank you.
Thank you, lovely. Thank you. Last but not least, can you both join me then? So.
Split the mic. Okay, right. Right, so taking this back to, I guess, what we wanted to do, which was a different perspective on the ethics-based assessment that was presented earlier today that Inej has done an incredible amount of work on, and what we see as the benefits and challenges. I'll start off as the rain cloud and you can do benefits and lovely. Challenges. I think the first is obviously the cultural considerations and the regional differences that you have whenever you bring up the question of ethics, and applying sort of a unified approach that takes into consideration the different ethical values, but also weights that different cultures give to those values. Things like we talked about, especially risk and accountability are weighted very differently across even just the group as we were speaking. So that's something that has to be taken into account going forward when we work with these ethics-based assessments. The second challenge is how we ensure sort of ethics literacy and continued education, because there's no point in everyone doing an ethics-based assessment if no one knows what they're talking about when they're speaking of ethics. So how do we keep that understanding where it needs to be? Third of all, speaking about trust between humans and AI and machines that leverage AI, what does that look like? How do you measure that? How do you assess that? How do you grow that? I thought some really basic questions just for you to come up with answers for by this evening. The second to last challenge we identified was we have a really large list of ethical considerations, but those considerations probably sit with different organizations or different entities. For me as a safety regulator, some of those considerations are probably not within my remit, but they will sit, for example, in Sergey's remit as a participant. So how do we identify where those differences and overlaps are? And the last one, I apologize in advance to all the engineers in the room, but multiple people raised the, and I understand this, the difficulty of demonstrating the relevance and benefit of ethics-based assessments in very safety-focused organizations. And how do I go up to one of my very busy, very, very incredible engineers and say, I need you to take time off of assessing the specific safety things you're used to assessing and start thinking about ethics, and showing how that actually does benefit in a safety relevant context.
We'll try just.
Thank you, lovely. Okay.
Okay, I have the pleasure to present the benefits of yet another checklist. I'm pretty sure everybody's excited as I am about, no, okay. So if you speak to an ethicist, and they will tell you, actually, checklist is the worst thing you can do in ethics, because ethics does not work with checklists. But everybody in this room, coming from aeronautics, I think we love checklists. So it does make sense, yeah? So what is the benefit, actually? The benefit is that a checklist allows even people who have not thought about these topics, maybe from the start a conversation. And because if the checklist is done properly, you will get questions which will point you in the direction, because you haven't thought about it. You thought about safety, but maybe there are components where something else might be touched. And always when a human is interacting with a machine, there are, especially in this area, there are regions where our values might be, let's say, endangered. And so the checklist might offer benefits starting from this one. Of course, it provides a unified framework. So if you had a unified checklist agreed upon from many organizations, it will simplify the life and you would know that other players will following the same approach. It provides a consistency and a framework for that. It addresses many of the issues which are important, especially in Europe, but we know that the challenge is that it differs from, let's say, region to region how important, for example, data privacy is. For people here, for many, and in Germany, we know it's very kind of important. The benefit is also that if done properly, it anticipates and reduces the anxieties of all involved, even inside an organization, and can actually, the hope is that it will help facilitate faster integration of AI. Not necessarily due to technical reasons, not necessarily maybe on board in the start, because there are many challenges with starting from hardware, going to certification, but at least it will speed up maybe uptake of AI in less critical regions, or maybe in DALD and lower risk profits. So facilitate rapid deployment, and the anxiety topic we have already addressed. So
Great,
that's all.
thank you. So, super. This is just a summary.
Yeah, sorry, we won't make you sit through all that again.
Very quickly.
No, yeah, so very quickly, to boil all those things down into 4 points each, the benefits that we want to reinforce going forward from the ethics-based assessment is the fact that it provides consistency, it can enhance trust, it can also enhance the deployment of AI, and it makes ethics usable and practical for people in the room. It takes it out of the solely philosophical realm and makes it usable for people. Challenges that we need to think about a little more is the perspectives that change across time and across generations, how we maintain people's training and competency on ethics so they can use this tool effectively, how we transform the engineers' perception from it being an administrative overhead to it actually allowing safety gains, and how we think about and address those cultural and regional differences. So we've just got a tiny bit of work to do. Yeah.
Thank you. Grand applause for you. Thanks so much.
Thank you very much.
Thank you.
And the rain stopped.
Okay, then I will pass the floor to Francois. And I think you'll pass the floor to somebody else, right?
Okay, so I welcome Florence de Grancey, who supported me during this session. Just a few words. We were a lot of people in the room, so we divided the room into two places. One group working mainly on the benefits, another group working on the challenges, and after some time we exchanged the two groups so that everyone could express their views on the two different sides of the slide. I will let Florence summarize what is the outcome of this of the session. We have kept all the different post-its that we received, and we will make use of them to go into the details of all these topics. Florence.
Okay.
Okay, thank you. So first of all, thank you all the people who participate to this extraordinary post-it session. This is only a sample, and you can see there is many ideas which was exchanged. So we are talking about assurance. We go trace forward to what are the benefits and what are the challenges. So regarding the benefits, the first one was the multi-domain approach, which facilitates harmonization and common vision. For example, some post-it talk about it creates clarity for the applicant. It enables engineers to be more efficient across all domains. So very good benefits for this regulation. Second benefit, ensure adequate management of monitoring of risk and safety risk. We all admit that we will not go into a plane if there is any risk introduced by AI, so the regulation allows to manage it correctly. For example, some post-it talk about specific use case risk analysis and mitigation approach, which allow to be confident. Some post-it talk about high risk are anticipated and mitigated before going to production, and safety as risk and assessment, so very important benefits. The other benefit is to have a shared framework for learning assurance process, which is shared between all of us. You can see we are labs, we are industry, we are regulatory, and we share the same framework, we share the same development process, and we can talk to each other and tackle the challenges regarding this development process together as there is a common ground. This is what some post-it talk about. We can build some best practices for AI development. We can improve interoperability, reusability of development method across all domains or across all stakeholders. And there is a very high collaboration within industry, research, and regulation allowed with this regulation. Last but not least, a benefit is that it favors the general acceptation of AI and the end user acceptation of AI, because as we have a clear acceptance criteria, as there is a solid ground process which is defined, it allows people to be more confident and to have more trust on the future system. Concerning challenges, to be honest, there was many posted because we see that there is still challenges to tackle concerning technology, regulation, and the process. But there is four main topics which can be extracted. The first one is the complexity to create data set with adequate quality. I think that every data scientist, every machine learning engineer, every AI scientist say, oh, if we have to do a representative data set, how we can do that, particularly for complex systems. We are not Facebook, collecting cat is not enough. So there is some post-its regarding data quality requirement, how we can collect corner case, and to be sure that we are really representative. How we can ensure the quality across multiple data domains, and we take a back vision about text and so on. Second challenge is about generalization. How we can be sure that the generalization of the machine learning model will be okay, the system will perform safely. And there is problem of how to create the generalization condition and how to verify the generalization. And we have many post-it which address this subject, and they extend to performances, to verification of learning process regarding robustness, how to create formal method, how to create generally method to support robustness, explainability, generalization. So for engineers and for researchers, you still have work to do. Last but not least, how to do verification method at the system level. We are mainly focused on how to verify machine learning model, but now when we integrate the model into a system, how we verify it, how we ensure that the system is safe, how we connect machine learning metrics to system metrics to safety assessment. So there is few post-its about that. Verification of system level requirement and compliance with expected behavior. How to clearly define when a system is safe or not, because it is not the same than software traditional. And last but not least, there was many post-its regarding how we extend the regulatory framework expressed by EASA to create some kind of sandboxes of gray area to be able to expose the system, to gain maturity on the system without making a risk on safety. And so to improve the maturity of his system. For example, some people talk about, I like the expression, room of innovation, exploratory of gray area of regulation, or the famous sandbox.
Thanks, Guillaume, and team, and everybody. So we were the group 3. We were looking at the kind of the human factors elements, the influence of regulation and how it might be a good thing or a bad thing. So we had a big group. We had over 50 post-its. There's 3 teams reporting. I'm not going to kind of go into the details because it's a lot of it. That was Denis' job. Denis did a fantastic job of synthesizing everything into one table, and at one point said, "Oh, we've got 2 tables. Is that okay?" So we've stuck with one. It's not just 4 points because I think there's a lot of richness in there, and just summarizing them, we'd lose that richness. So Denis is going to present. Thank you to the team. Thank you to Denis.
Yeah. So first, regarding the structure of the table, in fact, it explains by the fact that the question that was initially posed was that what are the benefits and the challenges of existing or planned regulation? And in fact, not everybody in the groups know exactly what is in the regulation. So it was easier for some groups to think about the benefit and the challenges about the introduction of cooperative and collaborative systems themselves. So this is why we have two big lines in the table. So maybe I will start by the second one, the second line, which is directly addressing the question of the benefits and challenges of the regulation. So we may expect that the definition of the AI levels and the associated guidance proposes a structural approach for the design. The regulation also will offer a codification of both safe behavior and foreseeable misuse of the systems, for example, over-reliance on complacency. But we can maybe a missing element would be to have some guidelines about the mitigation of those issues. And for example, by training, we would need to have some guidance about the identification of training needs for the using of collaborative systems. So the existing guidance offers the framework to better master human performance. We have talked of workload in particular, attention, human errors, and of course the quality of human decisions. And clear rules about task allocation, for example, for decision making, are expected. Now, if we look at the challenges about regulation as perceived today by the group, there is a complaint that the definition of 2A and 2B classification is too theoretical, and there are a few points to be clarified. And the first one is also about classification. It has been perceived that 3A and 3B system are presented or understood as the natural goal or the natural continuation of 2A to B system. So this maybe needs to be clarified. And despite that, it is assumed that the accountability for decision remains on the head of the pilot for 2A system. Some liability issues are still to be clarified. For example, what happens if an operator rejects a system from the AI, which happens to be a good recommendation? What about the liability of the user in that case? And to be clarified also, the implication for explainability of the capabilities of the system to collaborate with the user. This is mentioned both as a benefit and a challenge for guidance, which is some more guidance for training needs has been required. And we would like also to have more criteria to ensure the success of human system communication, in particular in collaboration framework when natural language is used. Expectation from the guidelines are also about the determination of the right level of transparency and explainability. And there are expectations also regarding data management and how to ensure data quality and the protection of data. And now, if we look at the benefits and the challenges which are expected from collaborative systems themselves, so let's see first the benefits. It's expected that such system, the deployment of such system, will ensure better quality of information in the cockpit. So it's concerned several levels of information. First, the quality of the input data used by the system, but also the capability of the system to better filter, cross-check, and enrich information provided to the pilot, and also to push information to the system which higher relevance than today's systems. We expect also to improve the decision-making made by the pilot. Of course, this is the main goal, the main operational goal of those cooperative systems. And collaborative and cooperative system should open additional training and simulation opportunities. And now, regarding the highest challenges for cooperative and collaborative systems, so those challenges that should be managed or covered by the guidance. First one is how to ensure, despite those systems are closely guiding the pilot, in particular for decision making, we must preserve the capability to deviate some rules in case of emergency. Even if those systems are supposed to be adapted to what the operator is actually doing, there is a risk of increase the workload, for example, by non-relevant communication. There will be an impact that is not fully measured today on human competency. And last point is that the decision by the system, like it happens by human pilots, the decision proposed by the system should be challengeable by the ATC. So I apologize if I missed some of the post-its. So as Andrew said, we have all the post-its. We will be able to make a cross-check when we have more time for that.
So is it me? Yes, yes, it's me. So good evening, everyone. I think that we had a very rich day today, and my intent is certainly not to try and paraphrase or summarize the day. But in fact, what I would like to do is to share with you a few reflections on AI and aviation safety in general, and put AI in perspective. In fact, this week is a very special moment for me because this is my last week at EASA. I'm going to retire at the end of the week. So it's been exactly it's been exactly 17 years that I've been working for EASA on different positions. And also on the 1st of September, it will be exactly 40 years that I had started my career in aviation. So 40 years in aviation and also mostly on aviation safety. And thinking of that, I started to remember of a few anecdotes that I heard when I joined my first company, so in '85. It was a medium-sized airline that doesn't exist anymore, UTA, Union de Transport Aérien. And during my first days and weeks at UTA, I had to meet I would say the old people of the organization, meaning those who had the age that I have today. And they told me plenty of anecdotes on aviation safety in the 60s, so back to the 60s. And I think there are many things that I could not tell, but there is one anecdote that really struck me, and that's the following. So one day there was a DC-8. Maybe some of you know what it is as an aircraft type. A DC-8 flying from Paris to Douala in Cameroon. And so we had a line mechanics there in Douala. And it happened that during the flight, it occurred a big hydraulic leak on one of the systems. So the aircraft landed at Douala. The leak to be repaired. So in fact, one pipe had to be replaced. And of course, there was no spare part at Douala. And it would have taken a couple of days to get a spare part to Douala. So the mechanics there found a very smart solution. He stole a bicycle. He cut the frame of the bicycle, took the pipe, and replaced the leaking part of the hydraulic system by this tube coming from the bicycle, and it flew back like that to Paris, and in fact, that was the safety culture at that time. And the guy was, of course, he was praised for that because he saved a couple of days of operation. And I think that having in mind the safety culture of today, I'm not sure that the person who would do that would be praised. I'm not sure, and I do hope that today we don't have aircraft flying around repaired by bicycle parts. So it shows all the changes in safety culture from that time. And also, I mean, if you look at the safety record from the 60s and you compare it to now, you see that the accident rate has been lowered by a factor of 100. It's huge. It's huge. And having this long career in the industry first and then with EASA, I could see all the development that led progressively to those safety improvement. And there is a common factor in all those improvements is that it has always been done in a collaborative spirit. And this is something that really struck me when I joined aviation in the 80s, is that already at that time, there was something which was really fantastic for me, for a young engineer, is that I had to deal with colleagues from all over the world dealing with aviation safety, and even between competitors. We used to collaborate to work together on aviation safety. And if I look back at the series of improvement that we put in place progressively, all the paradigm changes that we implemented, I have in mind the implementation of quality assurance in the 80s, human factors, especially in maintenance in the 90s, and then SMS, safety management systems. We really started at the beginning of the years 2000, and SMS was really a big paradigm change, especially from the regulatory point of view, because we moved from one approach that was, we had regulations that were designed as mitigations to pre-identified risks. So a system that was very stable, but very rigid, and that could not accommodate for new risks that we would identify. And this is why we identified SMS, to have this very flexible framework where you have still pre-identified risks, but the SMS is there to identify new risks, to follow them up, to monitor, and then identify new possible mitigating measures to be implemented and to be tailored to the need of the airline. And in fact, to do this, to implement SMS, we had to change our regulatory approach, because we had to move away from a system that was based uniquely on hard law and to have also soft law, because we need to introduce that flexibility to adapt the mitigating measures to the specific risks. And now it's back to my first years at EASA, when I joined in 2008, and I was responsible for a rulemaking department. We tried at a time to implement as much as possible this flexible approach based on soft law, and it was extremely difficult. Why? Because we had resistance a bit everywhere. Internally, our lawyers, I mean, they were horrified, because when you talk to a lawyer, the lawyer think legal certainty. So if you have a soft law, acceptable limit of compliance, there's no legal certainty. People can deviate, and then how can you enforce? So they didn't like that. Same thing with the Commission, and the relationship with the Commission on that topic was not very easy at that time, because they saw all the different domains that they were responsible for, and I had difficulties to understand why we were special in aviation. So they told us, no, I mean, hard law is what we want. Same with the member states, they had to implement and enforce the regulations, and they told you, well, I mean, AMCs, they are not enforceable, so we don't want them. And so legal certainty was the word, and our argument was at that time, I remember, we said, well, we are not there to make flying legal. We are there to make flying safe. And safe is about safety management. It's not about legal certainty. And Now, where we are now, we've seen the presentation on the NPA on AI. It is fully based on soft law, on AMCs. And of course, Giovanni, you said this afternoon that it's because of the legal mandate that would probably not allow us to develop hard law on AI. But I took part in the discussions with the Commission earlier this year on should we go hard law on soft law, and it was indeed the Commission to push us to base our rules on soft law, not only because of the possible legal constraint, but also because they told us, well, look, we are now fully engaged into supporting the competitiveness of the EU industry. And to support the competitiveness, to support innovation, you have to go soft law. So that's something that I found very reassuring to see that now we have this shared culture. And I think it is shared now also in this room and with the member states, and so now with the Commission, that soft law is in fact by default the preferred approach, and is only when you need to secure some legal aspect that you will use the hard law. One other reflection on the EASA mandate. When I joined the EASA in 2008, I would say the motto was EASA is safety only. We only focus on safety, and we've moved progressively to safety first, which is different, because safety first means, there are other things that we need to take on board. And I think one of the first thing we took on board beyond our mandate was innovation. And it was in 2017, so we are coming closer to the days of today. I had a meeting with the executive director at that time, and he told me the following. He told me, I have a concern with innovation because we see lots of development and currently, and it seems that the pace of innovation now is much higher than it has ever been in the past 50 years. And how can we cope with that? How can we support innovation, and especially how can we deal with the possible knowledge gap between us and those who innovate? And that was a key question, because when you need to certify new products, new systems, if the technology is new and you don't master that technology, there's a big risk. In fact, there are two possible risks. One risk is that you take a very conservative approach. You don't really understand. So possibly in the end, you don't certify at all. And it is true that the safest product is the one who will never never fly. So that's so. In terms of, I would say, economic efficiency, that might not be the ideal solution. And the second type of risk is that, well, you just fail to identify some safety risks. You certify the product, and then there's a big safety problem in the end. So bridging this knowledge gap was one of the objectives that we took on board in order to address innovation. And when I speak of knowledge gap, I would say it is also two ways. It's for our experts facing new technologies, but we had something which was also very new at that time. That is that we had plenty of newcomers joining the aviation world, which was also new as compared to the 50 previous years. We had the drone manufacturers, drone operators, air taxi being developed, blockchain solutions, AI, and those companies didn't come with any aviation background. And safety, one of the, I would say, biggest pillar of safety in our community is the shared safety culture. And so we saw all those people coming with no real safety culture, and that was a big concern. So how also to bridge this gap between us and the rest of the aviation community. And one of the things that we're implementing at that time, and we are going to discuss those tomorrow, is the so-called innovation partnership contracts. And so there will be two being discussed tomorrow. And this proved to be a very efficient tool for us to bridge this knowledge gap. What is an IPC? An IPC is a contract where we agree with a partner from the industry to work together on an innovative solution. We bring our expertise on aviation safety, and they share with us their knowledge on the new technology. And we work together, and we both learn on each other's knowledge. So we learn from the technology. The company learns from the aviation safety culture, processes, approaches, and everything. And also, we learn from the possible need of the industry to be supported to reach that knowledge of aviation safety. And I remember one of the first IPC that we had, Guillaume. It was also with you. It was on artificial intelligence, and on one of the first meetings, we shared, I would say, the basic elements of the project. It was on AI and also on aviation safety standards. So I remember a day where, there was a brilliant guy drawing incredible equations on a whiteboard. I didn't understand anything, but I think you could follow, Guillaume, fortunately for us. And then when it came to sharing how EASA certifies product and everything, we discussed the safety level, and we explained that we have a basic principle, that is that to certify a product, the bottom line is that the probability of a fatal accident caused by a single event is 10 to the minus 9. And we showed that to the guys, and they just laughed. They said, ha, ha, ha. They thought it was a joke, because they were used to deal with 10 to the minus 2, 10 to the minus 3. And then for us, it was like a new world. But how can we deal with that? And so that was one of the starting points, and it shows all the interest of the IPCs is that we learned a lot from AI, and they learned also a lot from the aviation safety approach, and we learn also from what the industry, the newcomers, need in terms of support. And what I would like to illustrate also with those IPCs and why it is so central in our approach is that, well, it is a collaborative approach, and you can see that collaboration with all interested parties is really at the heart of our approach, and that's why we are there today. We are there to collaborate and to develop solutions together. And it is also the basis for the development of our guidelines, AMCs, and everything. They don't come from nowhere. They don't come from a few bureaucrats in an office, drafting regulation. These come from real life and from practical experience that we got, in particular through those IPCs. One thing also on innovation is that we spoke on the mandate of the agency, and you spoke also on the mandate of the FAA. And when we started to work on innovation, it was clearly not on the mandate of the agency. So we decided to work on innovation. We didn't have the mandate, but we need to do it, and then we'll see what the Commission will say. And so we had discussions with the Commission and on that, and they said, I think you're right. You need to work on that without the mandate. And it's only a few years later than the basic regulation was amended, and it caught up, and it included innovation in the mandate. So just to tell you that sometimes we complain about the bureaucracy in Europe, but you can see examples where, on the contrary, the approach is very flexible, very pragmatic, and it was, in fact, exactly the same when AI came into the picture. When AI came into the picture, we started to work on the AI roadmap, Guillaume, to 2018. And then at some stage, and you mentioned that, I think, Ines, the EC published the ethical guidelines. And first, it was quite a shock to discover. And okay, we never considered that as a dimension of AI. What shall we do with this? And the first thing is that, well, it's not in our mandate, so maybe we should not touch that. And then, thinking and working on that, we realized that we had to integrate this in our approach, because we realized that the ethical dimension is not something that you just plug in at the end of a project. If you start working on a project ignoring the ethical dimension, you work with your data sets, with your programs, with everything. You end up with something. And imagine that we EASA, we certify an AI product or an AI solution without the ethical dimension. It has the EASA, the beautiful EASA certificate. And in the end, you have to put everything in the bin because it does not comply at all with essential ethical element. Then we don't, I think, as EASA, render a good service to the industry. So we, since the beginning, took the ethical dimension on board to do that, to make sure that we provide the right support to the industry. We were challenged for that because some stakeholders and also internally told us, well, it's not your business. Let us do our engineering things, and you should also focus on engineering things. And I think that with time, I think that more and more there is a common vision, and I can see that also from the workshop today. That yes, the ethical dimension is just a part of AI. AI is a special animal. AI in aviation cannot be considered in isolation. And I think that's the first time that we have that we have a topic in aviation that is one bit of a much bigger issue that affects the whole society. And we have to deal with that, and we can't ignore all the possible societal impact of AI. And this is why we've taken that on board. And this comes to something that Christine Berg said in the beginning this morning. She mentioned the three elements of our approach, and you can see that we are really fully aligned with the Commission on that. Is that the NPA on AI is there to fulfill three objectives: to support safety, to support innovation, and also to protect the citizens. And that's what we are doing. And I think that this is where we stand now on AI. We have this complex equation with those three elements to deal with. It's very complex, but it shows that also as it is complex, we have to continue to deal with in a very collaborative manner to get the input from all possible affected parties. And this collaborative approach, I mean, it's really our trademark for everyone. And I'm quite sure that proceeding like that in a very collaborative manner, we will continue to make aviation safer, to support innovation, and to protect the EU citizens. Thank you.